Good morning, madam. Yes.
Right. Thank you. We can start, right? So yesterday we start to talk about hypothesis testing. Actually, hypothesis testing means I have some hypothetical statement regarding what? Regarding the population parameters. No, regarding population parameters mean regarding we say that population characteristic, like population mean, population variance, right? Or population proportion, like mean, variance, proportion, standard deviation. Those describe your data, describes the data, right? If you have the sample, using the sample also, I can calculate sample mean, sample variance, sample standard deviation. For the population data also, I can calculate all these statistics, all these things. But the population, if you have the population, we call these characteristics as parameters. Actually, we don't know the values of the parameters. We don't know the actual value for the parameter because practically we have no population data, right? So what we do in statistics, we work with the data, right? So we select the sample. We select the sample from the population and collect the data and we analyze those data. So in the data analysis, uh, we mainly talked about the descriptive data analysis. That is how we describe the collected data. You can describe using graphs, tables, like summary measures like mean, median, variance, range, coefficient of variation. Right? So different types of data presentations we discuss. All these methods we describe the data for our variables. We describe pulse 1, we describe the weight, we describe the smoking habit, right? Activity level. We describe several types of variables. So now we are talking about some advanced part, advanced analysis part, that is called as the hypothesis testing. Hypothesis testing. Here, hypothesis testing, what we do, we have some hypothetical statement, right? Hypothetical statement regarding the population parameter. Here, mu is the population mean. Right? This is my population, and mu is the population mean. So I don't know, this is H naught I called as the null hypothesis, H naught null hypothesis and H1 alternative hypothesis. So when we write the hypothesis, right, hypothesis always, it should contain H naught and H1, right? You have to write H naught and you should, H1 also you need to write because H naught is what we assume, we hypothesize that this is true till our sample data shows that we can reject it or we can accept it, right? So here in this slide it says H naught is the hypothesis that is to be tested. We are going to test this one. What this says whether the population mean is equal to 2,500 or it is not equal to 2,500. So we always assume that this one is true. This one is true until we have sufficient statistical evidence, right? Until our sample data, how we test this, whether this is true or false, how we test this using our data. What are our data? I have the sample of data collected, right? Until this sample data gives evidence to you this is true or false, we assume that this is true. And so that is the thing we are doing in hypothesis testing. So there are several steps you need to follow when doing a hypothesis testing. And also in hypothesis testing, we test this hypothesis. We test this H naught using the sample data. But according to the sample data, sometimes according to sample data, after performing some tests, I can write my conclusion. I can write my conclusion. Right? I can write my conclusion whether H naught is true, H naught or H naught is false. If it is not true, it can be false. Right? Then when I come to the conclusion, right? I can come to the conclusion according to my hypothesis test based on the sample data. Finally, I can say that H naught is true or H naught is false. But actually, I don't know this is true or false. In actual situation also, this can be true or false. We don't know what is the actual situation, right? So according to this, these things, we can identify two types of errors, right? Although we test the hypothesis and give our conclusion, always two types of errors can happen. Two types of errors can happen. What are those two types of errors? We give names for those two errors, type 1 error and type 2 error. Both are errors. Right? I will explain you why I give the name for one error type 1 and the other error type 2. Why we use these two names? What is the reason? But those two situations, we do some error. ඒ අවස්ථා දෙකේදීම අපි යම්කිසි වැරද්දක් තමයි කරන්නේ. හරි දෙයක් නෙමෙයි. එරර් එකක් තමයි අපි අතින් සිද්ධ වෙන්නේ. මොකද්ද වෙන එරර් එක? What is this error? In the actual situation, in the true situation, right? In the actual situation, actually H naught can be true or it can be false. In actual situation, H naught can be true or false. But after collecting the data, we test this hypothesis. Right? So after collecting the data and performing the test, our decision, we come to conclusion like, I say, I reject H naught. I reject H naught from H naught, reject H naught වැරදි. I reject H naught. H naught is false. Or I can say I accept H naught. Right? Because I can say I accept H naught. H naught is true. So now when we look at this table, right? This table shows you something that is in actual situation. Sometimes in actually H naught is true here, but after the test, I come to conclusion, I give the decision and come to the conclusion like H naught false. ඇත්තටම H naught හරි. හැබැයි මම data ටික sample data අරගෙන test එක perform කරාම කියනවා H naught වැරදි කියලා. ඒක වැරද්දක්. It is an error. Right? Here also, this situation also we do some error. In actual situation, H naught false. ඇත්තටම H naught වැරදි. According to our test, we say H naught is true. ඇත්තටම H naught වැරදි. නමුත් මම කියනවා H naught හරි කියලා. හරි කියලා conclusion එකට එනවා. ඇත්තටම H naught වැරදි. That is also a wrong decision. Error. But these two are correct. These two are correct decisions. So when any hypothesis testing, these two types of errors can happen. ඕනම hypothesis testing එකකදී මේ errors යාපි දෙක අනිවාර්යයෙන්ම වෙනවා. But we say one error is more serious. One error out of type 1 and type 2 error, one error is most serious error. More serious. Right? So I told you that I will give some practical example for this, right? Please go to this table, and here you have some practical hypothesis, right? What H note says, right? H note says in the code, right? Suppose there is a person. This person actually H note, in H note side it says the person is innocent. ඇත්තටම මේ මනුස්සයා අහිංසක කෙනෙක්. Right? H note says person is innocent. So the contradictory one, H1 means person is not innocent. Right? So now suppose I am going to test this H note using some sample data. I test this H note, and in the actual situation, H note can be the population. Actual situation, H note can be true or H note can be false. Right? But I don't know what is, whether it is true or false. I don't know what is the actual situation. At the situation එකේදී වෙන්න පුළුවන් ඔය දෙකෙන් එකක් විතරයි. H note හරියන්න පුළුවන්. H note ඇත්තටම වැරදි එකක් වෙන්න පුළුවන්. Right? The sample data අරගෙන we test this hypothesis. Based on the sample data, we test this hypothesis and we get the decision and come to the conclusion that I reject H note. I say H note is false. Or I say H note is correct, true. That is, I accept it. Right? Now, please go to this table and tell me. Here, as the previous case, here you can see two types of errors. Right? Here, this one is an error. Here also, we have done some error. We have done our decision. Here we get the decision when H note true. We say H note false. It is an error. I have done some error when getting the decision. Here also, actually H note is wrong, but according to the data, according to the test, I say H note is true. Again, this is an error. My decision, I give the decision, but there is an error. Right? So, but these two are okay. ඇත්තටම H note හරි. මම කියනවා මගේ ටෙස්ට් එක තාමත් H note හරි කියලා correct decision. Right? In the actual situation, H note false. I say H note reject. That is, my decision is false. H note is false. Reject H note. That is also correct decision. So now tell me. According to this hypothesis, අපි හිතමු මිනිස්සෙක් ඉන්නවා, එයා අපි හිතනවා එයා අහිංසක මිනිස්සෙක්, innocent person. Then according to this hypothesis, two types of errors. What can you say? Which error is more serious? මේ දෙකෙන් මේ errors දෙකෙන් එකක් ඇත්තටම කියනවා serious error, more serious error එකක්. Type 1 error, type 2 error, එකක් more serious. Which one is more serious? Please think about your H note is a person is innocent, right? And think about what is the more serious error here. What is the most serious error? What do you think?
Type 1.
Type 1 error is the most serious error, right? Very good. Because type 1 error is the most serious error. We say type 1 error is the most serious error because what the type 1 error says, we reject H note when H note is true. ඇත්තටම H note හරි වෙලාවට අපි කියනවා වැරදි කියලා. ඒක තමයි most serious one. Right? That's error එකක්. But out of these two, this is more serious. Think about according to this example. If the person is innocent, actually, when H note is true, person innocent, I say he is not innocent. I come to the conclusion he is not innocent. And here H naught is false. H naught false means in actual situation, person is not innocent. Person not innocent. But I do not reject H naught. H naught වැරදි වෙලාවට H naught reject කරන්න H naught වැරදි කියන්නේ I do not reject H naught means I say person is innocent. Person is innocent. Right? වැරදි decision එකක්. දෙකම වැරදි decision, but this is more serious. Why? If the person is innocent, we say he is not innocent. Right? Here, person not innocent, but say we come to the decision and give the conclusion that he is innocent. It will not give big harm to the person. Right? But this one, in this case, actually that person is an innocent one, but we come to the decision that the court give the decision that the person is not innocent. It is very harm. Right? මේක තමයි most serious. මොකද ඇත්තටම පුද්ගලයා වැරදි පුද්ගලයෙක් නොවන වෙලාවට එයා වැරදි කියලා කියන එක තමයි අපි කියන්නේ වැඩිම serious error එක වෙන්නේ. ලොකුම වැරද්ද වෙන්නේ ඒක. ඒ මනුස්සයා ඇත්තටම අහිංසක කෙනෙක් නොවන වෙලාවට අපි decision එක දුන්නොත් එයා අහිංසක කෙනෙක් කියලා ඒකෙන් ලොකු හානියක් වෙන්නේ නැහැ. Right? It doesn't give big harm. But if the person is innocent, ඇත්තටම අහිංසක මිනිස්සෙක් වැරදි කියලා කිව්වොත් ඒක ඊට වඩා harmful. Right? So this is how we identify the more serious error. Always in the hypothesis testing, two types of errors can happen, type 1 error and type 2 error. According to the definition, type 1 error is reject H naught when H naught is true. Right? How I read this mark. This mark, we say reject H naught. Right? Reject H naught, that mark, this line says when. Reject H naught when H naught is true. How I read this way, right? Reject H naught when H naught is true. Do not reject H naught when H naught is false. After the H naught false, the right hand side is first. Right? First read. After the H naught true වෙලාවට එයා reject කරන එක තමයි more serious. Okay. So any questions? Right. Now, when performing the hypothesis, right, when testing this type of, you have this hypothesis and we get the sample data, and suppose I perform the test, I have to do some test and check whether the population mean is equal to this value or not, right? When doing this test, we need some values. Those values we called as alpha and beta. Right? What is alpha? This is alpha. And these are very important terms. Alpha means the probability of type 1 error. Probability of type 1 error. Beta means probability of type 2 error. These are some probability values. Alpha and beta are two probability values. This is beta. These are standard notations. Right? Alpha and beta are probability values. Probability of type 1 error and probability of type 2 error. If we say the probability, now you know that if it is a probability, it should vary, right? It should vary. Or it can take values, right? It can be 0 or 1, or it can be any value between these two values, if it is a probability, right? So we say alpha is the probability of type 1 error. We know that the type 1 error is the more serious error. If H naught is true, we reject H naught. That is the probability of reject. When H naught is true, we reject H naught. This probability right? This probability we denote as alpha. We say this one as some, we consider this as some supremum probability. Supremum probability, right? So supremum value is called the alpha, right? We give another name for this. It is like the level of significance. Level of significance of a test. Level of significance, right? Alpha means the level of significance of the hypothesis test, of the test. What is alpha? Alpha is the probability of reject H naught when H naught is true. This is some maximum probability, some supremum probability value. ඒක ගන්න පුළුවන් යම්කිසි සුප්‍රීමම් මාගයක්, උපරිම මාගයක්, maximum probability value එකක් තමයි අපි මේ alpha දෙන්නේ. Right? So when doing the hypothesis testing, always the researcher can decide what is his alpha. Alpha, what do you think? Alpha, then this is an error, right? Alpha related to the probability related to some more serious error. Then what can you say about this alpha value? It should be a value close to 0 or close to 1. According to the probability concept, right? So if we say probability is probability of happening something, probability of raining tomorrow, right? Probability of raining tomorrow. If I say this is 0 means doesn't happen, right? No rain tomorrow. No rains tomorrow. Right? If I say there is the probability of raining tomorrow is 1 means exactly you will get rain tomorrow. Right? Exactly it happens. Right? So this one, what do you think? This alpha is a probability value. I'm asking whether it should be a value close to 0 or close to 1. Now, according to the definition, alpha is the level of significance. That is the supremum or maximum probability of type 1 error. It is the some maximum probability, probability, right? Maximum, very maximum probability probability of type 1 error. Now think. It should be a very large value or a very small value.
Large value.
Sorry?
It's large value?
No. Surely it should be a very small value. Why is that? Because this is an error. Make up වැරද්දක්. අපි දෙන decision එකේ වැරද්දක්. Because this is an error and this is the more serious error. වෙන්න පුළුවන් වැරදි දෙකෙන්ම serious error එක. එහෙනම් ඒ වෙන්න පුළුවන් error එක we want to keep it at the minimum level. Because of that, this alpha should be a very small value. Right? Normally, we consider alpha as 0.05 or 0.01 or 0.1. Right? We don't take alpha as 0.9, very close to 1. Right? We take alpha with very small probability value because this is an error. Think about this practical problem. Right? The more serious error means when we are doing the hypothesis testing, definitely these two errors can happen because I don't know H naught is actually true or false, but according to my test, based on the sample data, I come to some conclusion, I come to decision and I use my conclusion. But my conclusion, my decision can be wrong. sometimes it can be wrong. We want to reduce the more serious error. අපෙන් වෙන්න පුළුවන් ලොකුම වැරද්ද අඩුවෙන්ම කරන එක තමයි වෙන්න ඕන. Right? So, what we do when performing a hypothesis testing, always researcher decide what is his level of significance. It should be a small probability value. Right? Here it says type 1 error, alpha, normally we take as alpha as 0.05, that means 5% level, or 1% level, or 10% level, and we get very small problem here. So then another one here, probability of type 2 error. Probability of type 2 error, we call it as beta. Right? We are not worried about this one too much because this is the most serious error. Right? And this is also important when doing the calculations, but researcher first decide this one. Right? So now you know that in hypothesis testing, you have H0 and H1. According to how we write the hypothesis, it can be one-tail test or two-tail test. And there are two types of errors can happen, type 1 error and type 2 error. Right? And out of these two errors, type 1 error is the most serious error. Right? And the probability, maximum probability of happening this type 1 error, we called as the level of significance, alpha. Alpha is the size of type 1 error, is the size of type 1 error. Right? That's the probability. Right, and also here, I got this one from your course manual. Higher values of alpha, less precise results. Not high. If higher values of alpha means very low precise results. The results are not good. So the researcher first decide what is alpha. Right. So now, let's go to another two types of main terms. Right? Is this sound disturb to you? ඔයගලන්ට මේ සද්දේ disturb ද? මං කියන එක පැහැදිලිද? Is it clear what I am saying? There is another sound is coming. ඔයගලන් disturb the sound එක? Can I continue?
Yes, madam.
Okay, right. Thank you. Right. Now, another terms we need to know. That is, when performing the hypothesis testing, right, there is another term like test statistic value, right? And critical values, right? What is a test statistic? Test statistic is some quantity. It's like some quantity, right? It has some formula. It is a quantity we can calculate. If you have the sample data, I can calculate some value for this. It is a value used to decide whether we reject H0, whether we reject the null hypothesis, or whether we do not reject the null hypothesis. Right? And that means when after writing the hypothesis and after deciding the alpha, I have to get the answer using the sample data for the test statistic value. And from this one, we come to the conclusion. We come to the conclusion according to the critical values. What are the critical values? Those are the values with which value of test statistic in a sample is compared to determine whether or not the null hypothesis is rejected. That is, we according to the critical values, right? If it also some value, we another value comes from the test statistic value, and we compare these two values and see whether we reject H naught or do not reject H naught. The critical value for any hypothesis test depends on the level of significance. So that value also I know. That means the researcher decide what is alpha. It's a probability value. It's a probability value. So I know according to the probability value alpha 0.05 or 0.1, I know this value also, critical value. I will show you how we get it, right? So then comparing with these two, we come to the decision, whether we reject H naught or do not reject H naught. Right? So this shaded area, suppose that my alpha is 0.05. So here we do this test based on the standard normal distribution, normal table, normal distributions, right? So if this is a probability 1, I know the standard normal table, this is 0, and this under this curve, the total probability is 1. This, since this is symmetric, for this side 0.5, and for this side, the probability, whole probability 0.5. Under the curve, we have the total probability 1, 8. Right? Now, if alpha 0.05, alpha is a very small probability here. Right? So I mark this value normally in the tails. Using tails, we mark this probability. Right? So 0.05 means this marked of a very small probability value, alpha. So I mark this shaded area as alpha. Okay. So using this, we can calculate what, using this probability, then I know this probability. If I know this probability, I can calculate what is this point here. In the z-axis, what is this point here? Okay. So using these values, we come to the conclusion. Okay. So I will show you what is the example, for an example, what is the test statistic and how we get the conclusion. So in hypothesis testing, we need to follow these steps. First, I have to define the parameters, then decide your hypothesis. Write the hypothesis and identify the test statistic, and you need the data, then define what is your level of significance level, and come to the decision and conclusion. So this is this one. I will show you for an example. Let us talk about test for one population mean, right? Here, I think you have this type of hypothesis. H naught is H naught checks whether the population mean mu is equals to some value mu naught, right? Suppose this can be any value. Suppose it is 2,500. Mu is equal to 2,500, other notation mu naught, versus the contradictory of this is H1 mu need not equal to 2,500, right? So how we write the hypothesis? It can be two tail, one tail, left tail or right tail. These are one tail. Right? These are one tail. Any questions? This is how, according to how I write equal and not equal, this is a two tail. That is, H naught true means mu equal mu naught. Otherwise, in this region, this from this side left tail or from the right tail, we say H naught false. H naught වැරදි කියන්න පුළුවන් මේ දෙපැත්තෙන් ඕනේ එක. H naught හරියන්නේ mu 2,500 වුණොත් විතරයි. එහෙම නැත්නම් H naught වැරදි. එතකොට H naught වැරදි වෙන්න පුළුවන් in both tails. So we say it is a two tails. right? But in this hypothesis, we have rejection region, reject H naught only in one side, one tail. So now I write the hypothesis, right? I write the hypothesis. Now it says that when you have a hypothesis testing, you need to collect the data, right? A very important assumption underlying test of significance of for the variables is the sample mean. This is some typically normally distributed if the parent population which the sample is drawn is not normal, right? Here I know mu has the population parameter, means the population parameter. I take the sample. We assume that these samples are very large samples and they are normally distributed. Sample means we assume that they are symmetrically bell-shaped, normally distributed. Right? Because we need that distribution when solving this. And we define a random sample. We select a sample of n number of data points from the population, x1, x2, up to xn number. These are my sample data, right? From a normal population with mean mu. This can be, the population also can be normal or not normal, but if you have a large sample, the sample means are normal. So when the sample is distributed, the population normal, sample means also normal, then the sample mean is distributed. That is sample mean, x bar, the mean calculated from the sample. This is also, you can say, this is normally distributed with mean mu, the same mean in the population, and the variance sigma square over sigma square divided by the sample size, right? So using these theories, there are developed test statistics, right? No need to worry about those theories and how these test statistics are developed, right? So this is the test statistic developed according to the theory here we discussed. This is the test statistic. What is this? Here it says sample mean minus mu naught divided by sigma over root n. This is some quantity. This is some quantity. We denote it as using the standard normal random variable, is it? Actually, we subtract the mean and divide from the variance. It's a standard normal, not x like it. This is Z. So this is we call as the test statistic for the one population mean test hypothesis. Now, using the sample data, you can calculate what is the value for this. This Z value I can calculate because I know x bar. What is x bar? According to sample, in sample, you have a sample. I know what is x bar. This is known. And mu naught, h naught is equal to mu naught. I know this one. If the distribution I know sigma naught, n is a known value. So all the values are known. So I calculate what is Z. So then what we do is we get the decision. Test criteria is this. Depending on the alternative hypothesis selected, the test criteria we decide. That is, H naught is H1 side is not equal side. It's a two-tailed test, right? So we get the decision using this one. That is this Z value, right? This Z here, this Z means the test statistic value. This Z means the value, this one. This is, I know if the sample data I have, right? And if this one mod value of this greater than Z alpha by 2, right? What we do, we reject H naught at alpha level of significance. That means what it means. I say if H1 side you have equal mark, I can reject H0 in two sides. Right? Here we reject H0. Right? Here also when mu less than mu naught, here also we reject H0 in the left side. Here I reject H0 in the right tail. Right? So these are one tail rejection. These are two tail rejection. This is two tail rejection. So now I know this Z value. Another value I have to calculate this one is alpha by 2. I know the alpha. Alpha is given by the researcher. Suppose alpha is 0.05. Right? You know it's some probability. So we are talking about this, the test statistic value follows a standard normal distribution. What I do here, right here what I do, I consider the standard normal distribution. Standard normal distribution, right? Suppose I want to test this first one. Right? So I have two rejection regions. So alpha, what I do is I divide this probability into two rejection regions. Right? If my test is a one-tail test, right? If my test is a one-tail test, right? In the distribution, only one tail, I mark this alpha, right? If you have only one rejection region in the distribution, in one tail I mark my alpha. This is alpha, right? This region we can reject it, alpha. And here alpha goes to both sides. So what we do for this region, I put alpha by 2 half because of the symmetricity of the distribution. For this one, alpha by 2 half. Right? Now what we are doing here is, now I know the value alpha. So I know alpha is 0.05, the probability value. For this case, suppose this is 0.05. And so by looking at the standard normal table, I can find what is this point Z. What is this critical value Z. Right? So I have two Z values. One comes from this test statistic and the other one comes from this standard normal distribution. By comparing these two, that is here in the left tail test, right? Here you Z alpha is a negative value. This one I can write as Z alpha. In notation Z alpha. Here this one minus Z alpha, subscript alpha, Z alpha, right? Here alpha by 2. Here Z alpha by 2. This side I have minus Z alpha by 2. Right? So what is the decision? How I get the decision here? My test statistic value. If my test statistic value falls in the rejection region, we say we reject H0. Our test statistic එකෙන් Z value එක දැන් මේ Z alpha by 2 හරි Z alpha හරි කියන එක standard normal distribution එක බලලා හොයාගන්න පුළුවන්. මේ value එක මම දන්නවා. හිතන්න මේ value එක මට ආවේ 1.96 කියලා. right? 1.96 කියලා. මේ test statistic එකේ value එකක් ආව නම් calculate කරාම 2.45 කියලා. 2.45 කියන්නේ මෙතන බිඳුව. In positive side, 2.45 falls in the rejection region. 2.45 කියන්නේ මේ හරිය value එකක්. ඒක rejection region එකට වැටලා තියෙනවා. So we come to the conclusion, right there, 2.45 greater than 1.96. So we reject H0. We reject H0 at 0.05 level of significance. Right? This is how we write the conclusion. when you go through your research articles based on the hypothesis testing, like you can see how we write this conclusion. We reject H naught at, this is very important. You have to mention under which level of significance the researcher gets decision. What this means, there is a chance of saying there is a chance of this decision be a wrong one. This chance is a very small probability. අපි මේක ටෙස්ට් කරලා decision එකක් දෙනවා. හැබැයි ඒක වරදින්නත් යම් chance එකක් තියෙනවා. ඒ වරදින්න තියෙන chance එක ඉතාමත් අඩු probability එකකින් තමයි තියෙන්නේ. එහෙම වෙන විදිහට තමයි we do this, perform this hypothesis test. Right? Any questions? This is what we do in hypothesis testing. So when we are talking about two population means the test statistic is different, right? And how you write the hypothesis is different. When you talk about another parameter, again you will get a different test statistics. So there are developed test statistics, right? So in your stage, you are not expecting those things, right? But you should have some idea about how we write the hypothesis, and if you give the test statistic and if you give some Z value, how we get the conclusion, how we come to the conclusion, right? So I want to explain you. Right? I will discuss. I will discuss this example only this example, right? I will discuss this one only. Because I'm not expecting these manual calculations from you at your exam, right? Because now we have the statistical software. If you know the theory, when you input the data and give the hypothesis, directly we can get the decision, right? But in your stage, we cannot use any statistical software. So I will explain how we come to the decision manually using this example, right? For this example, to get an idea, right? You can get some idea what is going on here. It's going on under statistical hypothesis, but I am not expecting these calculations at the exam, right? So after that, we need to discuss few points like test for differences of the means. I go through these, but I am not explaining and doing these examples, right? Because these are very difficult. I think these are difficult to understand within a very limited time period, but I will explain these things so you can get that idea that we can perform these type of hypothesis also, right? So for that purpose, I will explain these things. Otherwise, these are not coming for your exam, right? There are no questions from these for your exam. But you should know to write H naught and H1 and identify type 1 error and type 2 error. And if I give you a hypothesis and ask whether it is a one-tailed test or two-tailed test, you should be able to identify. Any questions? Right, I will do this example and go to the other parts, and we have to complete this lecture also. There is another one, like the regression, like under regression modeling. The lecture note, the last lecture note, I will upload this one. This is regression modeling, regression and correlation. I will explain this and give you how we calculate the correlation. This is very important, right? Very simple one and very important for you. So we can go through this one, and after that, today I will give you some questions, right? I want to discuss those tutorial questions with you. So I will give you some time, and after you finish those things, we can discuss those answers for these questions. Right. So, and before going to discuss about this hypothesis testing problem, I want to show you another one that is right. This is your assignment, right? I will upload this one to the LMS, right? This is your assignment. It has very simple 5 questions, right? So please complete this one, and you have to hand over this when you come to the exam. You have to hand over this to your department. You will get some marks for this. Very few simple questions are there. But to do these things, right, you should, I think it is better to complete the tutorial 1 and tutorial 2, right? I have uploaded this tutorial 1 for the LMS, right? We can discuss the answer today. And another tutorial, now tutorial 2, right? After the lecture, I will upload this one also, right? Here you have few questions. Today first you need to answer these questions, and after that I will discuss, right? So these are very helpful for your exam. Right, with for your exam, you will get some MCQ questions, and questions like the questions like this, right? Actually, no, no, like essay type questions. Some questions are essay type, but I will expect simple answers on it, right? Like these questions, and you should be familiar with this type of questions, and know with mathematical calculations. හරි ඔයගොල්ලන් මේ assignment එක මම අද දානවා මේක complete කරලා hand over කරන්න exam එකට එන වෙලාවට. ඊළඟට tutorial තව එකක් මම දානවා. ඒ tutorial දෙකේ questions අද කරන්න ඕන මේ lecture time එක ඇතුළේදී ඔයගොල්ලෝ කරන්න ඕන. කරයින් පස්සේ මම discuss කරනවා. right? ඊට පස්සේ බලන්න තනියෙන් assignment එක වල submit කරත හැකි. ඒකම මේ අනිත් මොනවාද තව කියන ඔයගලන්ට MCQ questions වෙනම exam එකට MCQ questions කීපයක් එනවා. MCQs එනවා, essay type questions එනවා. හැබැයි ඒවා ගොඩක් ලොකුවට ලියන්න දේවල්, ලොකු calculations තියෙන ඒවා නෙමෙයි. ඒ essay type questions those are like in this format. මේ format එකෙන් තමයි එන්නේ. Right? And also you have a LMS quiz. It is also contains MCQ questions on it. Okay, LMS එකකට පොඩි quiz එකක් දානවා. ඒක exam එකෙන් පස්සේ කරන්න පුළුවන් වුණා. ඒක next week දානවා. ඒකත් කරලා මේ submit කරලා තියන්න. Let's go to this one, right? Example. Now, please read this example. Right? So please read this example, and I will explain how it get the decision and come to the conclusion here. Read this example and see, according to the example, according to the question, what is the hypothesis, and what are the how we write the hypothesis, and what are the given information. Right? Please go through this. What this says, the mean timber yield obtained from 30 recently cleared plantations at age of 50 years in a particular management unit is 93, with standard deviation 10. Right? Test whether mean timber yield is 100 based on past records. Right? So you have to test whether the mean timber yield is 100. That means you are asked to perform some statistical test. Statistical test regarding the mean timber yield. Right? Actually, this is not the sample mean. Definitely, this should be the population mean. So I define mu, right? I will say let mu be the mean timber yield. Mean timber yield. We want to check this hypothesis whether mu is equal to 100 versus H1, mu not equal to 100, right? And another important thing in hypothesis testing is always the equal sign goes to H0 side. හැම equal sign එක තියෙන්නේ H0 පැත්තේ විතරයි. right? මේ H1 පැත්තට equal sign එක දාන්නේ නැහැ. ඇයි අපි test එක කරන්න යන්නේ? We perform the hypothesis test assuming H0 is true, equal 100. කියලා හිතාගෙන තමයි මේක කරන්න යන්නේ. නිසා equal sign එක හැම වෙලාවෙම H0 එකේ තියෙනවා. If we have like greater than 100, here this should be greater than or equal. Here, then this should be less than 100 this side. Right? So now, then now see what are the given information. Right? What are the given information here? Says mean timber yield obtained from 30 recently cleared plantations. So 30 plantation, that means the N. Now, your sample size, number of you selected 30 plants, right? In age 50. With age 50 years, you selected 30 plants and management and the unit age of 50 years in particular management unit is 93 with standard deviation of 10 with the standard deviation of 10, right? So the standard deviation 10 and right. The mean timber, right? Mean timber yield is 93. Right? This is given here. Mean timber yield obtained from 30 recently plantation. This is N of 50 age of years. This is no need. No, this is not used for our calculations. It is B, right? This mean timber yield means sample mean. So the sample mean is 50 years in a particular management unit is 93. That means sample mean is 93 and the standard deviation 10, right? And we want to test this hypothesis, right? Also, now I have one population mean, hypothesis testing on one population mean. For this is my test statistic. The statistic is this, right? So for the test statistic, I substitute the values and the Z value, now here Z value comes 3.834. So this is, right? So now what we need to do, we want to test this hypothesis, we need a critical value, right? We need a critical value to come to the decision. Okay? So I can decide alpha as 0.05 and come to the decision. Right? Alpha as 0.05 and I can draw the standard normal distribution. So this is a two-tailed test. This is a two-tailed test. So alpha 0.05, then I have to mark in two tails, right? Mark in two tails. This is 0.05 0.05 over 2. This is 0.05 over 2. And I have to find these 2 points and come to the decision. I want to check whether this value falls in this region or this region. Right? If it is in one of these regions, we can say we reject it. Otherwise, we do not reject it. We do not reject. Right? Now, I will show you how we see this from the standard normal table. Right? Go to the next example and right, get a few minutes and read this example. You have the answer also, but read the example and write down H0 and H1 and summarize the given information, that is find what is N and what is X bar, what is sigma or what is R. If we have given the sample standard deviation, what is it? Find all these things from the given information and what is alpha, right? Identify these values and calculate the test statistic value. Right? After that, I will show you using the standard normal table how I find these Z values and come to the decision and write your conclusion. Right? So please get 2 minutes, 2 or 3 minutes and get this answer. Z value should be 3.5. But we should go through this and identify these values and calculate this value. Any questions? Can you understand the information? Right? The information given in the question, right, using the standard notations. Here it says that the nutrition is claimed that a new dietary supplement can change the mean iron level in adults to 15. To test this claim, a random sample of 25 adults is selected. So it says a random sample of 25 selected, and that means N is 25, right? Selected, and their iron levels are measured. So we collect the data, right? So the hypothesis they have, it says that nutrition is claimed. That is some person claimed that a new diet supplement can change the mean iron level. So mean iron level among the adults from 50. Right? That is mean iron level mu. If we define mu is the mean iron level, right? After getting the new dietary supplement, it can change the value is 50. To test this claim, we select 25 adults and their iron levels are measured. So these are my data. I should have the data to test this hypothesis, sample data. So I have to collect iron levels, right? I have to collect the iron levels. This is my variable, iron level from 1, 2, 3 up to this 25 number of adults I want to collect this data. This is my sample, right? And after taking the supplement, so suppose the sample mean is found to be 16. So this sample mean shows it is 16. Right? So now I have some guess. Sample mean 16. I am checking whether the population mean is 15. Right? It will be different, but I can't say H0 is true or false by comparing these two. I have to perform some test, hypothesis test. So it says, assuming normal distribution of iron level, that is the data are normally distributed with population standard deviation sigma 2, right? Test the nutritional claim at 0.05 level of significance at alpha 0.05, right? So these are the given information. Also, I write the hypothesis H0 will equal 15 or U0 equal 15. These are given. So we have to use the test statistic Z value. So I have only one population mean test hypothesis for one population mean. Right, when I write Z means X bar minus mu over sigma over root 10. This is my test statistic. Right, under the theory, right, this is X bar minus mu naught over sigma over root 10. So, right, this should be mu naught. Right, so now substitute the values. X bar is 16 minus mu naught. Now I mu naught is 15, equal mu naught, right? We perform this assuming H0 is true. So this I can take 15 sigma 2 over square root in sample size 25. So this is the answer. This is the Z value. This is we call it the Z calculated value based on the test status. Right? Now I have to find another Z value. Another Z value I want to find using this level of significance alpha. Right? See how I find it according to the hypothesis test. Test whether it is a two tail or one tail. I draw this standard normal distribution. Right? So I have how many rejection regions are in this hypothesis? How many rejection regions are there? In standard normal distribution, the center is 0. How many rejection regions are there? Rejection regions mean from how many regions I can reject H0? I can say H0 is wrong. Right, I talked about the H0 using mu, right? I talked about the H0 using mu. Right, now I'm talking about Z level line. Right, so if we consider the mu, right, when mu is equal 15, we know H0 is true. If not, from this side or this side, you can say H0 false. H0 false. Right? So I have two rejection regions from the tail or from right tail. So I mark these two. Right? With alpha 0.05. So since I have two rejection region, I consider for this part, I consider the half of alpha. And here also the half of alpha, 0.025. Right? Now using the table, I want to identify what are these two values, what are these 2 points. Right? So alpha 0.025, alpha 0.025. So go to the standard normal table. Go to the standard normal table, right? So here, now I want to find, now I know this one. I know this one, that is alpha 0.025. Here also alpha 0.025, but if I find this value, because of the symmetricity, I can decide what is this. Right? So alpha 0.025, now these probabilities gives this area. So find out from these probabilities where 0.025 is value, right? This is 0.025. Right, the value here 0.0256, right? The probability value. This is the probability value. Now, according to the probability value, this line, this row, and this column number gives the relevant Z value. What is the Z value? Relevant Z value minus 1.9. Here, this point is minus 1.9. The second decimal place I got from here 9.5. So this is 1.95. So this side then should be plus 1.95. According to the symmetricity of the actually here we have ඊට මෙතන තියෙන දශම විග්‍රහ දෙක අටවම එකක් තියෙනවා මේක ගන්න පුළුවන් අපිට right 1.96 95 right here 0.025 so 1.96 and this is minus 1.96. Any questions? Okay, so this is the value. So this is 1.96 minus 1.96 plus 1.96. So these two values are known. This one is this is minus 1.96. This is plus 1.96. So now this is Z. This is right. This is Z alpha by 2 minus Z alpha by 2. This is plus Z alpha by 2. Right, now see your Z calculated value is 2.5. This is the Z axis, Z line. The Z line, this is 0. This is 1.95. So my 2.5 in the Z axis, 2.5 is a place right here. This can be this should be equal to 0.5. So Z falls, right? Z calculated value falls in the rejection region, that is, we reject H naught, that is the Z calculated value goes to rejection region, we reject H naught, we reject what is in H naught side at 0.05 level of significance, alpha level of significance, right? This is the decision. So what is my conclusion then? How will I write the conclusion? I can write that mean iron levels in adults after taking the new dietary supplement is different from, is not equal to 15, is different from 15 at 0.05 level of significance. This is very important to mention. In hypothesis testing, alpha is very important. You have to write under which alpha level of significance you come to the conclusion and you get the decision. This is called as the hypothesis testing. Right? I am not expecting this calculation from you, but you should know some theory parts. Right? You should have some idea about type 1 error, type 2 error, and writing a hypothesis, right? So you should have what is the level of significance, some basic things you should know. Any questions? Now, shall we go to these points and finish this one? And after that, I want to talk about the correlation analysis. And also, I have uploaded your assignment, right? Now, I uploaded your assignment to your LMS. From your LMS, you can download it. Please complete that one. Right. So, when talking about hypothesis testing, sometimes we have to talk about the differences of means when you have two populations. Suppose this is population 1 and this is population 2. This has mean 1 and this has mean 2. So I have to test this hypothesis whether these two means H naught mu1 equal mu2 versus H1. These two population means are not equal, right? Or we can write as H naught psi H1 mu1 greater than mu2. Then the can predict the alternative on this one. Then H naught mu1 we are greater than or equal to, then this should be mu1 less than or equal to mu2. Right? Like you see, we can write the hypothesis for the two population means. In that case, this is the test statistic, right? This is the test statistic we have to use. It also follows a standard normal distribution. And again, as the previous case, we have to calculate this value Z cal, and we have Z alpha, right? According to the, we have to decide, the researcher has to decide the level of significance, and while comparing these two, we get the decision according to whether the test is one phase or two. So there is an example also, right? We can go through this, and also we can talk about the hypothesis testing regarding certain proportion of suppose you have this population is a certain forest, right? With the population you have trees. You have trees, right? Suppose you want to identify the proportion of diseased trees, capital P, I use the notation. I want to identify the proportion of diseased trees. Proportion of diseased trees. So suppose in the population I have 50,000 trees in the forest. Out of these 50,000 trees, I want to identify what is the proportion of diseased trees. Right? Suppose you have some hypothetical statement that proportion of these trees is equal to 20%. We can test this. H1, this is not equal to 20%. We can test this. How we test this? Right? How we test this? I have this hypothesis regarding the population parameter. Now this is my parameter. Now it is not mu. It is not mean. Now it is P, population proportion. Right? So how I test this? How I test this? We select the sample. We select the sample of trees. Sample of trees. Suppose I select sample of 500 trees and check whether how many trees are diseased. Out of 500, how many trees are diseased? I can get the sample proportion value, simple P. Using this data, we can test the hypothesis. I have the sample data. Right? So in that case, this is the test statistic. Here, simple P is the sample proportion, and we get the decision like this way. But again, we have a Z cal value and a Z table value. Z critical value. We call it as a Z table value based on the standard normal table. There is another example also related to the population proportion. Right, and when we have two population proportions, right, we can test this type of a hypothesis whether the two population proportions are equal or not. So again, you need to use another test statistic and come to the decision according to this test criteria. Right? So this is another types of case, that is when we have small sample sizes. That is, earlier I said you, we have the large sample sizes. Large samples mean the sample size. We practically we have to decide what is the sample size. Right? Practically we say if n greater than or equal 30, we say it is a large sample. N greater than or 30, it is a large sample. Okay? That is to apply the hypothesis testing and some advanced statistical part theories, we need some data. You should have a sufficient number of elements in your data points in your sample. Right? If your sample size is, suppose your sample size is 6, you have only 6 records. If you collect the height of the plants from 6 plants, that means you have 6 data points only. What can you do from these 6 data points? Can you see the variability? No, it is not enough. Right? We always say we need a sufficient number of data points to analyze. Mainly for the descriptive statistics, it is okay. But if you are going to do like confidence interval calculations, like hypothesis testing, we need more information. We need more information. Right? So we always try to get the sufficient data, large sample. So if you have a large sample, we say sample is a large one when your sample size greater than or equal to 30. In practical situation, this is the point you consider my sample is a large one. But in some situations, we cannot get the sample of size 30 also. Right? In some practical situations, it is difficult to collect the data. Right? In that case, we have separate statistical techniques to analyze those data, like non-parametric test. Right? So here, when we have small samples, right? When we have small samples, what we do is we cannot go for the standard normal distribution. Right? We have to work with the T distribution. This is another distribution. We have to work with T distribution and another test statistic we have. Right? This is the test statistic. So according to the test statistic, again we can come to the conclusions whether we reject H naught or not. Right? So this is the T. Probability standard normal table. This is the T distribution. Right? T distribution means it is also a bell-shaped distribution, but not like in standard normal distribution means 0. It has longer tails, larger tails. Okay? And the shape of the distribution, we say, depends on the degrees of freedom. It varies from degrees of freedom. Right? It means degrees of freedom. It can take different values when the degrees of freedom vary. Right? The shape of the distribution also varies. Here, these are the degrees of freedom values, and this is the probability, this upper tail probability. If you know this probability and the degrees of freedom of the distribution, I can calculate this table value, this T value. Okay? This is how we read the T distribution. And this is an example of a small sample size situation based on the T distribution. Right? So I'm not going to explain these things. Right? This is for the difference of the two population mean when you have small sample sizes. There are different types of test statistics we have to use. So these things I'm not going to talk, right? Explain to you. But when you have free times, you can go through these, right? So, and this one I want to explain. This is paired case. That means sometimes when we have to test for the two means, sometimes the two population data we can consider those as two paired observations. For an example, here in an experiment on some of the plots were divided into two equal parts each. One half of the plot receives soil treatment A and the other half of the plot receives soil treatment B. Each plot was planned with some this type of treatment, plot number, the same plot, but it gives the two types of treatments. So we say these are paired observations. So we have to use another type of hypothesis testing or statistical test statistic when solving this one, right? So here the difference of these two data points are meaningful. So we can calculate the difference and perform the test. So we say we have paired data. Now what I want to do is, I think, right, we want to finish the last one. Before that, right, I will finish the last one. Before that, the regression part, I will do it in the evening, but before that, you please, I will give you some time. Please complete, right? Please complete the first three questions in the tutorial number 1. And if you can, no, first three, 1, 2, 3, and 5 questions. Please complete these 4 questions in tutorial number 1. After that, I want to discuss it. Right? I will give you some time. I will give you 10 minutes to complete it. Right? Please complete question 1, 2, 3, and 5. After that, I want to discuss it. Right? And also, I will upload the tutorial number 2 to the LMS. You can try it. We can discuss all these things today, right? So get some time and go through what we discuss and try to answer these 4 questions Did you finish? We can discuss those two. Here it asks to specify whether the following variables are discrete or continuous. Right? You need to say this variable. Here you have A, B, C, D. You have given 4 variables. Whether this variable according to the think about, right? Read the variable name and think about what will be the data points for this variable. And according to that, you can decide whether this variable is a discrete variable or continuous variable. Right? If we say number of defective items in a production batch, number of defective items in a production batch, in a production process. I suppose that in production process, they produce items. Some items can be defective, some items can be good one, non-defective. So the number of defective items in a production batch, what are the data points can be? Which data points this variable can take? Give me answers. මොන වගේ data දෙන්න පුළුවන් number of defective items in production මොන වගේ தත්ත්ව දෙන්න පුළුවන්? Tell me, is it a discrete variable or continuous variable? The discrete variable එකක්ද continuous variable එකක්ද?
Variable.
Sorry? It's a discrete the continuous. It's a discrete variable. Right? It's a discrete variable, not continuous. It's a discrete variable. Why is the number of defective items in a production batch? If we think about the number of defective items in a production batch, what are the values it can take? Right? මොනවද ගන්න පුළුවන් මේ variable එකට අගයන්? Sometimes there are no any defective items. It can be 0. Sometimes there may be 1 defective item. Sometimes there may be 2 defective items, 3 defective items, 4 defective items. Suppose the batch size is 100 number of items in the batch. අපිට මේ batch එකේම තියෙන items ගන්න 100ක් කියලා. එහෙනම් this one can go up to 100. Only discrete values. Number of defective items in a production batch is a discrete random variable. This is not continuous, discrete. Right? It can take only discrete figures. Discrete. Points here. Discrete. මේ අතර අගයන් ගන්න බෑ. Is it clear? Number of family members. Number of family members can be 1, 2, 3, 4, 5, 6, 7, like that. Number of children in a family. What are the data points it can take? Number of children. There we know any children. 0, 1 children, 1, 2, 3, 4, like that. Number of rooms in a house. 1, 2, 3, 4, 5, 6, like that. Only discrete figures. Is it clear? Then tell me what is the variable type? Monthly income of a family. Think about the families and monthly income of a family. What are the data points that this variable can take? Monthly income of a family. and whether it is a discrete or continuous.
Continuous.
It's a continuous one, right? Right, I need your answers, right? So you have no extra time to go through the notes and prepare for your exam. Next week, Sunday, you have your exams, I think, right? 21st. So please do these questions and uh, go through the notes and try to answer this question, right? Then you can understand the theories that we learn, right? Because you will get very simple questions for your exam. But if you don't have any clear idea about the theories, what we have discussed, you should not be able to answer, right? Correct answers, right? So go through again and again what we discussed and try to understand. Monthly income of a family is a continuous random variable. This is a continuous variable. Why I say it's a continuous variable? Because if I consider the data for the monthly income of a family, right? Monthly income of a family, it can vary. It can get any value in between two defined values. Right? Suppose in our area, right? If I consider the several families, their monthly income can vary from those 50,000 to 75,000. The maximum value goes up to 75. The minimum value, the lowest value 50,000. If I consider one family, their monthly income can be any value. It can be 50,000, 75,000, or infinite number of values that it can take. Right? So it's not discrete, it's a continuous variable. In the continuous scale, it can take three values. If some variable can take the data points within a two defined points, it can take any value in between two defined points, it's a continuous variable. If the variable can take only discrete values, discrete figures, right? Discrete, right? This serial 1, 2, 3, 4. Then in between these two, there are no observation it can take. So it's a continuous random variable. See, is this a discrete or continuous? Number of machines in a gym is
Discrete.
so discrete, right? So discrete because number of machines can be 1, 2, 3, 4, 5, 6 up to any discrete number. Maximum, it can take some discrete number, discrete figures only. We cannot get number of machines like 1.5, 2.75. Those are not possible values. Right? So this is discrete. So the area of lawns in square feet, area in square feet. If we consider some area in square feet, then it's a continuous random variable. Continuous. You can take if we consider some area, can take continuous number of values in between any two defined points, right? It's not discrete, it continues. But keep in mind this point, that is, right, if we say monthly income of the family, we say it's a discontinuous random variable, right? But when you go to data points, when you go to the data points, right? For an example, suppose in the pulse data set, right? In pulse data set, here suppose I add the column, add another variable. Right, in the next column I add the monthly income. monthly income of the family. Monthly income, right? So when I add monthly income, the first student monthly income can be 15,000 rupees. Right? The second student monthly income can be 35,000 rupees. The third one monthly income can be 24,000 to 20,000 rupees. Like this way, when I see the entered data, I can see some discrete figures. I can see discrete data fine, but when we go through the actual meaning of monthly income, right? When we go through the actual meaning of monthly income, it can take any value. It can take any value in between two defined range. But when we go through the entered data points, when we see the data points in your column, we can see discrete figures, but it is not discrete, it is continuous. It is a continuous variable. So always we say, don't look at the data points in your data set, go to the definition of your variable. Right? Read the definition of your variable. What this variable gives you. According to that, come to the conclusion like whether it is a discrete one or continuous. Right? Any questions? Any questions from identifying discrete or continuous variable? Now send me your answers for the question number 2. Specify the class of measurements of the following variables. Scales of measurements, whether the ordinal, nominal, ordinal, interval, ratio. Right? The order is nominal, ordinal, interval, and ratio. Like we say, when you go from nominal to ratio scale, we have a lot of information. Right? We can talk about the ratios also. And in the nominal scale, means just we have only categories. We cannot order these categories. Right? But when we go to the ordinal scale, we have categories, but we can order these categories. Data points are like in categories, but I can order these categories. Right? Interval and ratio scale are like same, but the difference is here in interval scale data, the ratio is not meaningful. I cannot define the ratios, but ratio scale data, we can define the ratio and also the 0 point. Mean into 0 point has the ratio scale. You tell me age of an employee. Age of an employee. If we consider an employee and his age, if I record the age of an employee, is it what is the scales of measurements for this variable?
Ratio scale.
It is ratio, right? This is ratio scale. Because the data are, right? Data ratio scale data here we have. We can define the ratios also. Data not like in categories. Like if we record the age, the first person age 52. Second person age 45. Third person age 71. This is a continuous random variable. Ratio scale measurements. Ratio scale data you have. I can define the ratios also. If first person age is 50 and the second person age is, suppose his age is 25, I can talk about the ratio between these two ages. Right? And if I say age is 0 years, 0 has two meaning to it. Age is 0 means nothing. But in an interval scale, not like this, 0 means not nothing. right? It has some relative meaning. So this is ratio scale. So the second one, B, favorite baseball team. Right, I asked from the respondents, I asked when collecting the data, I asked, what is your favorite baseball team? Whether it is, I can collect the data like this way. Think about which type of data this can take. Like baseball team, suppose the team I have here, like we can talk about three teams, team A, team B, or team C. And one of this team name, right? We can get as the answer from the responder. අපි කායෙන් හරි අහුවොත් ඔයගොල්ලෝ කැමතිම බේස්බෝල් ටීම් එක මොකක්ද කියලා. ඒගොල්ලෝ ටීම්ස් තුනක් ගැන නම් කතා කරන්නේ. මේ තුනේ එකක් තමයි උත්තරේට දෙන්නේ. පළවෙනි කෙනා කියයි B team, second one says C team, third one says again C teams like that. I will get the answers like some categories. Right? So your answer is correct, right? It's a nominal scale. This is nominal scale because I have the answer points like nominal categories, but I cannot order these categories. I cannot say that A is greater than B, B is greater than C. You cannot say. Right? So it is nominal scale. Then the part C, body fat percentage of a person. It is body fat percentage is ratios. This ratio scale. Fat percentage of a person. We can say that, right? It is a continuous scale variable, right? We can define ratios also. So this is ratio scale. If the body fat percentage 0 means no person, nothing. Height of a plant, again it is ratio, right? This ratio scale measure. Last one, opinions of farmers on a new regarding new type of fertilizer. I collect the data regarding new type of fertilizer. So I collect the data from farmers. I have to ask the question like, what is your opinion regarding this new fertilizer? So what's the answer?
Ordinary.
Yes, it's ordinal, right? It is ordinal because you will get the data collected as the farmer can say very good. We can ask, we can give these choices. Is it very good or good, neutral or bad, very bad? We can ask from the farmers. Then farmer can give some answer. We can say bad. We can say very good or good. Like that. So we get the answers, data points like some categories. Categories, but we can the special properties, we can order these categories. I can say very good is greater than, very good is greater than good. Good is greater than neutral. Right? Very bad is less than bad. We can order. So it is ordinal scale. Let's go to the let's go to the last one. Right? Last question. Calculate mean, median, and mode of the following data. Calculate the mean, median, and mode for the following data. What is the mean of this data set? Now please go through the lecture note from the, you can open this lecture note. Right, from here, we talked about the calculating mean, median, mode, then we discussed about the percentiles, quartiles, right? Then range, standard deviation, right? Please go through this and identify. Right? There are two answers in the chat box, and these answers is correct. And the answers are, right, let's see if these answers are correct or not. Mean is 16.625, right? Median is 15.5. So the two answers, and mode is 40. In the exam also, if I give you this type of a small data set, you should be able to calculate these measures. Okay. We under the note number 3, in note 3, section of 3, we discuss a lot of things. Right? There are a lot of formulas. We discuss several things because here the first thing is the measures of, we discuss about the measures of central tendency. Measures of central tendency means how we talked about the center of the data. Right? I told you that suppose you have this pulse 1 data. When you have this 92 number of data points, how you talked about the center? You know this pulse 1 data, yesterday I showed you, I can plot this using a histogram. Right? Using a histogram, I can plot this, and the overall shape, when I draw a line, go through all the bars of the histogram, I can get this type of a curve. Right? This x-axis as the data, pulse 1 or height. So it is important to know how we summarize this data. How we summarize, rather than drawing graphs, how we summarize this data using some statistics. Statistics කියන්නේ අපි කියනවා මේ සංඛ්‍යා අපි පාවිච්චි කරලා කොහොමද මේ data graph වලින් පෙන්නනවට අමතරව මේ data ගැන summary එකක් දෙන්නේ කොහොමද? මේවා describe කරන්න කොහොමද? describe කරන්න පුළුවන් මේ data ටිකේ mean එක, cent එක ගැන කතා කරලා. මේ data ටික මට describe කරන්න පුළුවන් කොහොමද pulse 1 what are the මේක distribute වෙලා තියෙන්නේ? What is the center of the pulse 1 data? And I then describe this using the spread of the pulse 1 data. Data variability. Pulse 1 data can vary from here to here. Dispersion. Right? Measures of dispersion. So, when talked about the center, we say measures of central tendency. We can talk about, we can describe, we can do the descriptive statistics for some data by considering the central tendency measures as well as the dispersion measures. Right? Other than that, you can talk about the skewness also, whether it is a symmetric one or skewed one, like skewed to right tail or left tail. We can discuss. These are some descriptive methods. Yeah? So to talk about this center, we can use mean. Mainly we use these three: mean, median, and mode. Right? Other than that, we have several other measures like weighted mean, harmonic mean. Those things we use for special types of situations, special cases. Other than these, we have another measures like percentiles, P25, quartiles, Q1, Q2, deciles, right? We call these as some location measures. These are not the center, percentile, right? According to how the data are divided, we can talk about these location measures. It's talked about some location. We discuss these things. So when we want to calculate percentiles and quartiles, we have the formula. But you should know what's the theory behind this, what is mean by the quartile, right? So please go through this theory, right? And when calculating the mean, median, and mode also, mean, median, and mode, this is a simple formula. Simple arithmetic mean, take the summation and divide it from n, right? So for this example, in the tutorial, for this example, how I calculate the mean, right? The formula is mean is simply get the summation of these observations, sum these data points and divide from the number of data points, right? So in notation we write this like this way, that is x1 plus x2 plus, right? Because I have n number of data points, xn, I divide it from n number of data points. Like this is x1, this is x2, this is x3, right? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 number of data points. So now I substitute the value 16 plus 25 plus 14 plus 17 plus 14 plus 18 plus 15 plus 14, right? I get the summation and divide from 8. So it gives the answer. Right? So what's the answer? I think the answer is correct, right? So calculate this one. Right, 16 plus 25 plus 14 plus 17 plus 14 plus 18 plus 15, again 4. To divide this from 8. 16 point, answer 16.65. So when you have simple data points, you can simply calculate the arithmetic mean. And how we find the median? Median means the middle point of the ordered data set. Median means the middle point of the ordered data set. Median means the middle point of the ordered data set. Middle point of the ordered data set, that is what we do. And I want to order this data set. I want to write this data set in ascending order or descending. Right? I write this in ascending order. Right? The lowest value is 14. Then the next one 14. There are 3 14s. 14, 15, 16, 17, 18, 25. Right? So in this order data set, what is the middle value? Right? How we find the middle value? Middle value is this observation, this cancel out. This observation, this cancel out. This observation, this cancel out. This observation, this cancel. The middle value we have to calculate using these two. There is no one observation comes as to the middle point, right? Because we have even number of data points here. 8 number of data points, you cannot find directly, you cannot find the middle one. Right? So how we calculate them? Get the average of these two is the median. Median is 15 plus 16 over 2, right? 31 over 2, 15.1. The median value of the data set. Right? If there are another point, 9, like the odd number of data points, you can directly find the middle value. If some value comes from the middle point, midpoint, see a median. So median, what are the properties of the median? What's the meaning of the median, right? This is the median value. Median means the middle point of the data set. It divides the data set into two equal parts. Below the median, we have 50% of the data. Above the median, we have 50% of the data. Like those things you should know. Right? And mode is the highest frequent value of the data set. Highest frequent value of the data set. So the highest frequent value is 14. 14, we can see 14 is appear in this data set 3 times. It is the mode. Highest frequent value. So if I plot this data in a line, right? Suppose this line shows the like x-axis is data. So the lowest data point is 14. The next one, 15. 16, 17, 18, 19, 20. Like you see, there is a 25. The last value 25. So there are 314. So I can put 3 dots. 115, 116, 117, 118, and 20. So this is the distribution of the data. Right? Highest frequent value. Right? This is like this type of a shape here. Highest frequent value is 40. Histogram and the graph like dot plot gives this value. So we discuss a lot of things under this. There are a lot of theories under the lecture note 3, but if you have this type of very simple data set, very easily you can calculate these 3 central tendency measures. These are talked about the center. Distribution के मैं बगैर कमाई पता करो. Right? This is called as average. Average. So when we go to this lecture note, you can find a lot of very complex formulas, right? So these formulas we have to use according to how you receive your data set. Which type of data set you have to calculate these central tendency measures, we need to use different methods. Because of that, there are several formulas, right? Here, suppose you have the data like consider the following frequency table. What are the data you have? DBH values. DBH values, here I have no DBH values like individual data points, but you have the DBH values as some class intervals. The data given like this way. Tell me how many data points are there in the DBH values? How many data points are there? By looking at this table, you can give the answer. How many data points, how many DBH values are collected? The DBH values 3ක් collect කරලා තියෙනවා. දැන් data අපිට දෙන්න විදිහ අනුව මෙතන data දීලා තියෙන class intervals වලට DBH values බෙදලා එක class intervals වලට වැටිලා තියෙන DBH values වල frequency එකක් එක්ක. right? එහෙම දීලා තියෙනකොට mean එක හොයන්න ගියාම මට data ටික එකතු කරලා data ටික එකතු කරලා මට කියන්නේ නිකන් number of observations ගන්න බෙදලා mean එක හොයන්න බෑ. I cannot calculate the mean like that's previous in the tutorial. Here data is in different format. That's like class intervals. So then how you calculate the mean? You have to use this formula. Tell me how many data points DBH values are here. DBH values here. Right here, DBH values are divided as DBH values measured in centimeters. Right? It divides into several class intervals. The first class, DBH value 11 to 13, number of trees 11. Right? Then DBH value 14 to 16. Number of trees 20. DBH value 17 to 19, number of trees 30. Like this way, DBH values divided into several class intervals, 5 class intervals, and you have given the number of trees belongs to each class interval. So totally you have 80 number of trees. ඔක්කොම 80ක් data points තියෙනවා. මේ data points 80 individually මට පේන්නේ නැහැ. You cannot see these data points like this. Right? Just I can say there are 11 number of trees, DBH value from 11 to 30. 11යි 13යි සෙන්ටිමීටර් අතර DBH එක තියෙන +11ක් තියෙනවා. එච්චරයි කියන්න පුළුවන්. මම දන්නේ නැහැ මොනවාද individual values කියන්නේ. ඒ 11ම DBH value එක 13 ගානේ වෙන්නත් පුළුවන්. So I can't say. Right? So here you have, right? Here you have the data, not like raw format, the data has some summary format, frequency table. Because of that, we use this formula to calculate the mean. Right? Because of this, we use this formula to calculate the mean. How we calculate the mean here, get the midpoint value. Right? I consider the midpoint value. I don't know these 11 trees. What are the individual values for the DBH values for these 11? So I consider the midpoint of this class. That is 11 plus 13 over 2. Right? 12. So I assume that there are 11 trees with 12 centimeters. Right? So that is this 11 times 12. So I consider each midpoint value of the class interval represent the frequency, number of trees. Right? So then we get this summation and divide it from, get this total number of, here it should be, I think, 1,383, right? Divide it from 80, you will get the answer. This is the arithmetic mean. Here I cannot find the mean as previous. Is it clear? Right, so in calculating the median also, right? Median also, we have to use that type of formula, right? There is another formula for when calculating the median, when you get the data as a frequency table. Right? So if I give you this frequency table, definitely I should provide this formula. Otherwise, you cannot remember this, right? You cannot memorize this at your exam, right? I'm not expecting memorizing these formulas. If you want this formula for any calculation, I will provide, right? So don't worry about these formulas, right? Just go through what is for the purpose of these formulas, why these formulas we use. In the mode calculation also, when you have individual data point, simply you can find the mode. But if you have the data like in class intervals, you have to use another formula. This is the formula to calculate the mode. right? So, any questions? Now, right, so this graph also important, right? When you look at this type of shape, we say this is a symmetric distribution, symmetrically distributed. If the data are symmetric, the center is here, symmetric around the center, data symmetric, right? Both sides symmetric around the center. So, to talk about the center, if the data symmetric, mean, median, mode, all are good. All are good. Talked about the center because the data are symmetric, right? But here, data are not symmetric. Data are skewed to this side. Right? Or if you have this type of a shape, data skewed to left or right. Right? I said you here, this is like, suppose these are the exam marks, right? Most of the marks in this frame. And there are few number of students very low marks and few number of students with high marks. Because of that, we get a bell-shaped curve for the marks. This is the normal thing. Right? But in some situation, there may be a chance of getting these type of cases also. Right? In mathematics papers, right? There are few number of students obtaining very high marks. Most of the student marks are in this range, like below 60. Most of the students are here. Because of that, this curve goes up and down here, go down here. You see few data points here. Here also this is in another way, right? Like lot of people obtain more good marks, right? This curve goes up here means here we have more data. Very few data points are here. Very few number of students. Few students obtain very low marks. Most of the students obtain high marks. Like the easy papers, for the easy papers, we get like Buddhism. Right? The students score high, most, a lot of students get high marks. Very few number of students get very low marks. Because of that, the distribution is not symmetric. It shows some, it skewed to, it is asymmetric. Or it is skewed to one side, left side or right side. In this type of a situation, I said to you, the mean means actually mean, median, mode not falls in the same place like here. Mean goes to this side. If your data skewed to left, mean comes to here. Right? Mode is the place here because this is the highest frequent value. මෙතන තමයි උඩටම මේ කර්ව් එකේ ෆ්‍රීකවන්සි එක වැඩිම ෆ්‍රීකවන්සි එක දැන වැලියු එක තමයි නිසා තමයි මෙතනදී මේ පීක් කර්ව් එක උඩටම ගිහින් තියෙන්නේ පීක් එක highest එක. Right? This is the mode. This is the mode. Mean goes to place like this. And in between these two, we can find the median. Median place in between mean and mode. If the data are not symmetric, basically, right? And also I said you, when you have some unusual observations, right? Mean is not good to calculate because when calculating the mean, we get the summation of all the data points and divide it from n number of data points. So it is not good. In that case, median is good. Any questions for this exam? Let's go to the next one. Now, how we present the data, right? Question number 3. Which graph you are going to use? represent this one, this graph. Right, for the exam also, I will ask questions from, if I give you to draw a graph, I will give you the graph bar chart only, right? Only bar chart, not, I'm asking to draw pie charts or histogram, right? We should be able to draw a bar chart for the given data, bar diagram. bar chart එක විතරයි මම අඳින්න manually අඳිනවා නම් අඳින්න දෙන්නේ. Histogram එක අඳින්නේ නැහැ. The suitable graph to represent this data is the bar chart. According to the data you have here, you can decide it. Right? But you cannot draw a bar chart for this. Weekly wages, you cannot draw a bar chart for this. You have to draw a histogram. Because weekly wages is a continuous random variable. Right? In here, the question number 3, you have the variety. You have 4 types of varieties. We have 4 types of varieties. Right? So then, how we present this data? We'll be using bars. Right? You can draw a bar chart. Bar chart is what? For the x-axis, you have the variable variety type. For the y-axis, you have the yield, the frequency. Variety 1, varieties has 4 categories. 4 categories, and you can draw the, it should be a straight line, right? Draw the yield. Yield vary from minimum value 80 to maximum value 150. So you can mark the range. Here, you can mark it as 25, 50, 100, 150. You mark the range. Variety 1, yield 150. So we draw 1 bar. We draw a bar with height equal to 150. Right? Height equal to 150. The variety 2, yield 80. Right? So we draw another bar, which here the value be 80. Variety 3, 100. Variety 4, 120. Yes. This is how we present this data. For the 4 varieties, yields are vary as this way. Right? This is the suitable diagram to present this one. You can draw for this one, you can draw for the pie chart also. Right? Using the pie chart like a circle and slices. Here you have these 4 slices, but I'm not expecting to manually drawing the pie chart, right? Because today we have the software. So there's no need to waste the time to do these things manual calculation. Here we have to calculate the percentage values manually and draw the chart, right? So I'm not expecting to do it. So this is the bar chart, but you should be able to, in the exam, you should be able to draw this type of a bar chart manually. මේ bar chart එකක් manually අද ගන්න පුළුවන් වෙනවා. හැබැයි histogram එකක්, එතකොට pie charts ඒවා දෙන්න කියන්නේ නැහැ exam එකේදී. හරි මොකද ඒකෙත් තේරුමක් නැත්නම් calculations වලට කාලය යන්න දෙන්නේ. ඔයගොල්ලන් software එකක් ඉගෙන ගත්ත දවසට ඔක්කොම කරන්න පුළුවන් තමයි. But you should know what is the idea. Right? You should know you cannot do a bar chart for the weekly wages. It is not meaningful. The weekly wages වගේ bar chart එකක් හඳුනන සම්පූර්ණ වැරදි. ඒක තමයි කියන්නේ histogram. Right. Now, any questions in question number 3? So when drawing the bar chart, you have to mention the 2 axes and you have to number right? The categories And these bars should be equal in equal width. The size of the bar, height of the bar shows the frequency, right? The number of observations. So how you comment? How you tell something by looking at this bar chart? What you can say? What you can say by looking at this bar chart? මොකද්ද කියන්න පුළුවන්? මේ bar chart එක දිහා බලලා මොනවද කියන්න පුළුවන්? What are your comments? If I ask you to comment on this bar chart, what you can say? If you like, you can color these bars with the same color. You can add some pattern. මොනවද මේක බලලා කියන්න පුළුවන්? What are your comments? So, right. We can talk about, right? Very good. We can talk about the higher speed and the lower speed. Right? Manoj, which variety gives the higher speed? Which variety gives the lower speed? Right? So we can say the variety one gives the higher speed. Variety 2 gives the lower yield. The yield given from variety 3 and 4 seems to be same. And so you can write plot by looking at this graph. Right? So in your exam also you should be able to write it. Comment on your graph. Okay. So then the next one is right. Yes, we can talk about the differences also, right? We can talk about the difference of the yield between these two varieties. Right? But the most importantly, we can talk about the maximum highest yield, lowest yield, and compare the yields of different varieties. So then the next another point I want to say, right, suppose that I will give you, right, we discuss about lot of charts. We talked about several graphical outputs. Right, so this is the bar chart. This is the bar chart. Right? This is, and this is the pie chart. So if I give you this type of a diagram, pie chart, you should be comment on this. And here the pie chart shows the composition of the sample composition, how this sample consists according to the gender, right? This slide, this slide shows the male percentage. There are 62% of males. There are 38% of females. So we can see that the highest number of students, so majority of the students are males. Okay? So like this way, you should be able to write your comment, tell something by looking at these graphs. So if I ask the question like this, right, this is the histogram, right? Histogram of the height data, heights. So can you tell me what is the suitable central tendency measure? What is the suitable central tendency measure we talked about the center? We talked about the center of the heights data. What is the suitable central tendency measure? මේ histogram එකේ තියෙන height data, right? Height. එතන මොකක්ද හොඳ suitable central tendency measure එක වෙන්නේ? height එක ගැන කියන්න. center එක ගැන කතා කරන්න මොකක් කියලාද හිතන්නේ හොඳ? It's mean, right? Mean is good because when I look at this histogram and the overall shape of the data, right? Overall shape of the data, overall shape of the height values, you can identify the heights are distributed like this way, right? So approximately symmetric around the center, symmetric around the center. Right? So you can say the suitable central tendency measure, we talked about the center of height data is symmetric because the distribution of the data is symmetric. Is it clear? So please go through this, right? So if I ask you what are the 5 summary measures, 5 number summary measures we can get from the box plot, you should be able to write these. Box plot, how we go using these 5 summary measures, minimum value of the data, maximum value of the data, and we need to know what are the 3 quartiles, Q1, Q2, and Q3 quartiles. So can you tell me an approximate value by looking at this box plot? This is called as a box plot, right? This is because it has a box, and I cannot see any individual data points here. Right? Like this program also, I cannot see any individual data points. I have some data points in the x-axis and the bars, right? Here also you have the data marked in this y-axis, right? Y-axis data 100, 100, 120 like this way, and the box plot. There's a box and the 2 tails. Tails, it goes to some point. So can you tell me what is the value, approximate value for Q2 by looking at the box plot? In the box plot, this value, right, gives Q1. This value gives Q2, Q3, right? This is dynamic line, lower line here. This is Q1 124, right? Q3, the value here, and this is Q2. This line here, this point here. So by looking at the box plot, we can identify Q1, Q2, and Q3 values. Okay. So please go through these, what is given by Q1, Q2, and Q3, and these Q3s. Now, what I want to do is, I'm not going to talk about question number 4, right? We can do this, but I'm not giving to draw the histogram based on this type of a frequency table, right? So, if you have free time, you can complete this one by going through the lecture notes. But now I will upload another tutorial, right? It contains 3 questions only, only 3 questions. Right, 3 questions. Please go through these 3 questions and I will give you a break. Right now, the time is 11:20. So we can get 20 minutes break. Right, we can get 20 minutes break. And please join again at 11:40. Right, please join again 11:40 a.m. and I want to discuss the questions in tutorial 2. Now I upload the tutorial to LMS and please complete these 3 questions. Right, so after that we can discuss your answers. And so please join again at 11:40. And please, for your exam, right? For your exam, as a practice, the department is not providing you we are not going to provide you the past exam papers, but I will give you some model questions, right? Other than these tutorials, next week, I will upload some module questions also. So you can try those things. And the past papers upload වෙන්නේ නැහැ. ඒක නිසා මම module questions ටිකක් upload කරන්නම්. ඔයගොල්ලෝ ඒක ටිකක් practice කරන්න. ඊට අමතරව මේ tutorials වල තියෙන questions ටික කරන්න. tutorial questions ටිකයි LMS එකේ quiz එකයි assignment එකයි sample questions ටිකක් next week by Wednesday වෙනකොට කරන්න. Okay? But please join again, get a 20 minutes break and join again at 11:40. Do the questions in tutorial number 2. Find this, the first one, tutorial number 2. The following are lethal dose of toxin recorded for 6 experimental mice. Right? We have 6 data points. We have the data points are these are the data. A variable is lethal dose for these 6 individuals. And using this data, you are asked to calculate range of the data and the standard deviation of the data. Range and the standard deviation. Earlier, we talked about how to calculate some central tendency measures. We talked about the center. Now we are the range, standard deviation, variance, those are the measures we can use to talk about the dispersion. Dispersion, right? I will ask one question. Suppose that you have, right, for these 6 here, for the 6 mice, you have this data. Suppose that for these 6 mice, you have the data like this. First mice, the data point is 3.0. So the second one also 3.0. Third one also 3.0. The lethal dose, right? Fourth one, lethal dose also 3.0. Fifth one also 3.0. Sixth one also 3.0. Now, tell me, is there any variable, or can if you calculate the variance of the data? Variance. Is there any variability of the data points? Can you calculate the variance here? What do you think? Can you calculate the variance? When we talk about the spread of the data, spread or dispersion, right? If we see the distribution of the data, suppose the data like behave like this around some center, and the center is the mean. Around the mean, right, we get different values for data. We can get different values for data. Here you can see on the original data set, you have different values, 6 data points. Here you can see some variability of the data. Here you can see some variability of the data points. Now, in this data, there is some variability of the data point. One data point is 3, another one recorded lethal dose is 1.5, the third one 1.0, like this way, different data. There is a variability of the data points. There is a dispersion of the data. So we can talk about the variance, standard deviation. Right? So we can talk about the variance of the data, how the data vary from the center. Right? If here in this distribution around the center, data variation from here to here. Suppose you have a distribution like this. Okay. Now, this is the center, data variation is here to here. They have low variance than this. Right? So we can talk about the variability of it, but for this data set, there is no variability of the data. All the data points are same. There is no variability. If we calculate the variance, you will get 0. Right? So now with the idea, what I am talking about, the variance. Variance කියන්නේ දත්තවල පැතිරීම. පැතිරීම මොකක් වටාද? මැද අගය වටා. මධ්‍යමයේ වටා දත්තවල පැතිරීම තමයි අපි variance එක කියන්නේ. හැබැයි variance එක දත්තවල පැතිරීම measure කරන්න පුළුවන් ආකාර කීපයක් තියෙනවා. right? Measures කීපයක් තියෙනවා. Range එක පුළුවන්. Range. then mean deviation, standard deviation, variance, right? There are several measures. විවිධ measures වලින් like center එක ගැන කතා කරන්න mean, median, mode ඒ වගේ measures තුනගේ spread එක data වල පැතිරීම ගැන කතා කරන්න විවිධ measures තියෙනවා. හැබැයි ඒවා එකිනෙකට වෙනස්. There are some special properties. Some measures are important for some data. Right? Some measures are not good. Some measures are not good for some data sets. Some measures are not good for some data points. How the data points? So you have to decide according to your data. You have to decide what is the suitable measure. Right? Why I say like this? If we consider the measure like range of the data. What is mean by range? Go to the north and see range means the difference between the highest value and the lowest value, maximum value and the minimum value. Simply I consider the highest data point and the lowest data point in the variable. Right? So this lethal dose, the highest lethal dose is 3.0. The lowest data point value is 1.0. So difference, the range is 2.0. So for this data, the range is 2.0. Simply, the range means the maximum number minus the minimum number. Right? So when calculating the range, this dispersion measure, I'm not considering all the data points in the variable. I'm not considering all these 6 data points. Just I want to know what is the maximum value and the minimum value. Maximum minimum data points දෙක විතරයි මට ඕන කරේ. අනිත් data points මොනවා වුණා කමක් නැහැ. ඒ දෙක විතරක් තියෙනවා නම් ඒක කතා කරන්න පුළුවන්. So we say range is not a good measure. We talked about the dispersion. Right? We talked about the dispersion. Actually, range is not a good measure. The good measures are standard deviation, variance, and mean deviation also good measure in some situation. But mainly we talked about the standard deviation and variance. Okay? So now it comes to calculate the standard deviation. Now go to the lection of and see what is the formula for the standard deviation. What is the formula for the standard deviation? Right, and the dispersion measures standard deviation formula for the sample data. Right, when you have the sample data, the formula is this. Standard deviation formula is this, right? So now you, if you have to calculate this one, standard deviation or variance, for the exam, I will provide this formula. Right? May standard deviation calculate කරන්න නම් මේ formula එක මම දෙනවා. ඒතකොට මේක පාවිච්චි කරලා කරන්න පුළුවන්. Right? So what is the formula? Standard deviation. The formula is summation, right? Xi minus xr squared over n minus 1, the square root of this. Right? Xi minus x bar square. X minus x bar. X means data points. X minus x bar means the mean. We get the difference and the squared value of this difference and get the summation. summation over all the data points and divide it from the number of data points minus 1 and finally we get the square root value. අන්තිමට අපි වර්ගමූලය ගන්නවා මේ එන උත්තරේ. It is the sample standard deviation because I am talking with the sample data, right? So this is the formula. Now you need to apply the formula and calculate the standard deviation. So what is the easiest way? First you need to calculate. First you can calculate. First you need x bar, sample mean, right? First you need to calculate x bar. Then from each xi observation, from each observation you need to get the difference of each observation from the mean x bar. Get the square value and get the summation. Right? So very easily we can do this if you create this type of a table. Right? Here I have data points, xi values. X. Right? So what are the x values we have? 3. First data point 3.0, 1.5, 1.0, 1.5, 2.4, 2.6. So I write down the data points. And these are the data. Now, what is x bar? X bar is the summation of this data 3 plus 1.5 plus 1 plus 1.5 plus 2.4 plus 2.6. We divide from 6 number of data points. From this we get the mean. Right? Now what I do, I want to calculate this term xi minus x bar. Xi minus x bar. Right? So I construct the new column xi minus x bar. Right? And find these values. Then I can construct another column. I can find the square of these values. Use the calculator. 1 plus 1.5 plus 2.4 plus 2.6. Okay. We divide this from 6. And so the x bar is 2. Right? Now calculate xi minus x bar for each data point. xi3 minus 2 is equal 1. 1.5 minus 2 equal minus 0.5. 1 minus 2 minus 1. 1.5 minus 2 or minus 0.5. 2.4 minus 2. 2.4 minus 2, 0.4. 2.6 minus 2, 0.6. Now get the square. 1 multiplied by 1. Right? 0.6 multiplied by 0.6 multiplied by 0.6. So 1 minus 1 times minus 1 plus 1 minus 0.5 square. 0.5 minus 0.5. Right? 0.4 times 0.5. Minus 0.6 times 0.6. Okay? So you can calculate all these 6 values and get summation. And it's the summation of xi minus bar square. Okay? So from this you can find, now you know where you put this. Any questions? And n minus 1, what is n? N is n minus 1. N minus 1 is n is 6 data points minus 1. 5. So you can substitute the values. Value here and here we have 5 and it gives the standard deviation. Is it clear? Any questions? Right, can you, now I think you can, if you give a question like this, can answer, right? Can calculate the standard deviation and the range. That's I will provide this formula, right? But you can calculate this is very easily. You can calculate it if you construct a table like this. Otherwise, directly you can apply, substitute the values here and calculate. Okay. So, can you give me the answer for question number 2? Give me your answer for question number 2. As you can see, says a random variable x follows a normal distribution with mean 50 and standard deviation 10. Right? That means it gives some information about the about the distribution of the variable, distribution of the data in the random variable. Height data, how this data behave, what's the mean, what's the variance. Its distribution has a name also. The name is the normal distribution. Symmetric shape with mean this and variance this. Right? So this random variable x follows a normal distribution with these 2 parameters means you can write down the distribution as this, that is in notation, right? I can write as x random variable follows, right? X has normal distribution with mean 50 and mu and sigma square. What is sigma square? 10 square. Right? This is sigma square. This is mu. If x is converted into a standard normal random variable, what we do is we convert x into z. Z is the standard normal random variable. Find the mean and the variance. What is the mean and the variance? If we convert x into z, what is the mean and the variance? Answer in the chat box. Mean is 2. No, it's wrong. Not 2. Mean is not 2. What is the mean? What's the mean? If we convert this into a standard normal random variable, we say, right? Let's go to the north where we discuss this one. Right, now the answer is correct, right? Mean is 0. Not Z, you cannot write it Z 0. It not Z 0, Z equals 0. The mean of the Z distribution is 0. When we talk about the distributions for random variables, the normal distribution is very important. We discussed about several distribution, binomial and Poisson also. But normal distribution and the standard normal distribution is very important because you know that when we are talking, discuss about the statistical hypothesis testing also, right? Statistical hypothesis testing also, we have to use the standard normal distribution, right? It is a distribution, standard normal distribution. It is a normal distribution. If I say normal distribution, it's a symmetric shape, right? It is symmetric. It is symmetric around the center. It is symmetric around the center. Normal distribution is symmetric around the center, right? What is the here? This x-axis shows my random variable x. We say x has a normal distribution with mean mu and variance sigma star. That is, center is mu, mean is mu, and the variability is sigma square. It's as a normal distribution. Right? But if we convert this into a standard normal means what? Standard normal means we convert x, this x we convert into Z. Standard normal. What we do here, Standard normal distribution means how we convert it, how we construct the standard normal distribution, right? How we construct it. What we do is it means from x values we subtract the mean. We standardize. Right now in A-level marks we talked about the Z-score values, some standardization, right? We subtract the mean and we divide from the variance. It's from x values we subtract x minus mu over sigma. This quantity we denote as the Z. Another random variable. This is another random variable, and you say Z follows a normal distribution with mean 0 and variance 1. This is a standard one. Standard one. This mean 0 and a variance 1. Right? The two parameters, right? Mu is equal to 0 and the variance is sigma square is 1. Okay. So this is the relationship between the normal distribution and the standard normal distribution. Is it clear? Right? So it has this type of a shape. The same shape, symmetric distribution, standard normal. Now this line shows not x, this is right under the Z, right? The center is 0. Center means 0 and the variability is. This is standard norm. And the table values, these tables provide you the standard normal probabilities. Right here, I told you to use the graph I uploaded to the LMS. Right here, this shows this probability, this whole probability. This graph is not clear here. This graph shows like this. And the whole probability less than this. The whole area probability is from these values. Okay, so the answer for this question is mean and variance are in standard normal distribution. Mean and variance are mean is 0, variance is 1. Right, here the mean, we say the mean is when we convert this x random variable to a standard normal one, right? Always the mean is 0 and the variance is 1. Variance is 1. It comes to like this type of a shape. Same symmetric distribution, but the mean 0, variance 1, standard normal. How we construct the standard normal? Z1 how we construct, right? From x we subtract mu and we divide it from the standard deviation sigma. It becomes a new random variable Z. It follows a normal distribution with mean 0 and variance 1. We use the name for its standard normal random variable. Right? Standard normal random variable. Is it clear? Now, let's go to the third question. Right? Third question, what are the probabilities for these three plots? You have given some experiment, a coin toss twice, a coin toss 2 times, then what is the probability of getting 2 heads, getting 2 tails, and getting head and 1 tail, head and a tail? Right? Could you please give me the answer? And what you need to for this type of a question, as please practice these things. You will get these questions for your exam, right? The similar questions. Let's calculate. Right? Before we do the calculations, first what we need to find. First, what you need to find, you need to identify what is the sample space. What is the sample space for this experiment? After that, to answer the questions, probability of, now part A, I want to find the probability of getting 2 heads. Right? Write down what you want to calculate. What is the question in your terms, right? After that, you can convert this into some notations. Second one, probability of getting 2 tails. Probability of getting 2 tails. Getting 2 tails. The third one, I want to calculate the probability of getting 1 head and 1 tail. These values I want to calculate. So what is the sample space? The coin twice, toss 2 times. The coin toss 2 times means if I toss the coin first time, 1 time, what are the possible outcomes? If I toss a coin 1 time, the possible outcomes can be head or tail. Head or tail. The possible outcomes can be head or a tail. Right? The first time I can get head, this is the first time. 2 times we cross this one. So if first time I get a head, second time also I can get a head or I can get a tail. We call this as a tree diagram. Tree diagram. Right? So we use this one to identify the all possible outcomes. All possible outcomes in the experiment. All possible outcomes in the experiment. The first time I can get a tail. The second time I can get a head or a tail. So the all possible outcomes, finally, when you go to the branches of this tree, then finally we can find first time we get and the second time we get head. This branch, this one, right? This branch gives first time we get head, second time tail. This branch, first time we get a tail and the second time we get head. The last branch, first time we get a tail, second time also we get a tail. So the sample space is head, head. One outcome. Second outcome, using a comma, you can say, write the second outcome HT, the third outcome TH, right? And the fourth outcome TP. These are the all possible outcomes in the experiment. Any questions? Right, there are answers in the chat box. I think all the answers are correct, right? Now identify how we calculate the probability of getting two hits. Probability of getting two hits, right? So I said you can count how we calculate this. Suppose this is your event A. If I use some English capital letter to be getting two hits in this event, I can write this as I want to find the probability of event A. Right? This is getting to it's some event defined on the sample space. So probability of event A, how we calculate using the number of item elements belongs to event A divided from the number of elements belongs to sample space. Right? Number of elements in the sample space. For related to getting two hits, we have only one item, one outcome. So the answer is not correct. Okay. So the next one, getting two tails. Getting two tails, right? Again, only one outcome. We can see two tails. So the one out of four possible outcomes. The answer is one out of four. Okay. Probability of getting head and a tail, getting head and a tail, head and a tail. Right? If you get this outcome, again we have a head and a tail. Here also we have a tail and a head. Right? So for two possible outcomes out of all four, this is the answer, 2/4. Right? Any questions? Next, I want to, after the lunch break, I will discuss the last part, correlation and the regression analysis, right? And we will get one question from it. So please attend the lecture. And before that, I want the answers for the probability calculations. I want your answers for these four questions. Right? Using the standard normal table, I uploaded to the LMS. Try to find the answers. Calculate these probabilities using the standard normal table for part C to part A. Okay. I will give you 5 minutes and after that we can discuss. First, you need to draw the diagram. Draw the standard normal table. Draw the standard normal distribution and mark this point. Mark this point and mark where mark the area according to Z here. Z greater than 2.01. So mark the area and calculate the probability. Right? I will do one for you. Right? So how we do this? Suppose you want to calculate this probability. Probability is Z greater than 2.01. Right? Here, if we see this notation is said, right? Always this is we use in statistics to denote the standard normal random variable. Right? That means is said follows a normal distribution with mean 0 and 1. So no need to worry about other distributions. If you look at this, if you see this notation, is said anywhere capital is said, you know that it shows a standard normal random variable. Right? So the distribution of it is like this. Distribution is symmetric around the center. Right? The center is 0, mean is 0, and the variance is 1. So I want to calculate the probability Z value greater than 2.01. Right? So this line shows the x-axis. Here x-axis shows the values for Z. Right? The middle value is 0. So the right hand side you have positive values, left hand side you have the negative values. So mark 2.01. 2.01 is plus 2.01. So I can mark it in this way. Here, like point like here, right? This is equal 2.01. Right? Now I want to, the probability means area under the curve, some area under the curve. So I want to find which area belongs to this one. That is, I want to find the probability is it greater than 2.01. Then identify where is it, what is the area, is it greater than 2.01. 2.01 is here, is it greater than 2.01 means if is it is any value from here to here, that means is that greater than 2.01. So I mark this point and this is the area. This area gives the answer. This area shows this probability. This shaded area shows this probability. Right now, so now for part D, E and F, you need to mark this area. First you need to mark the area. Right? After that, get the standard normal table and see what's the probability. Any questions here? Any questions of marking this area? So this is the marked area. This is the area I want to find. That means this area gives the probability is said greater than 2.01. Okay. Right. So now go to the standard normal table. Right. Now in this table, you can see this table shows the area to this side. Right. This table shows the area for the Z values in the positive side, and shows some the total area from positive Z values to here. So we'll say it's like a cumulative product. Right? Here also from a negative Z value, here it is 0, negative Z value is to here, total problem. So it's a cumulative problem. Another name, right? So now what I want to select, from which table you can calculate this probability. You can use both, right? You can use both tables to calculate the probability. You can use both tables. Right? One So this is the area you want to calculate, right? You can use both tables. You can use both tables. Because if you can use this one, this table, or you can use this table. Right? Suppose I use this one. Right? Here my Z is a positive value, no? Z is a positive value. So when I see this relevant to this Z value, right, I want to find the probability. Probability is this area, this is area. So relevant to this Z value 2.01. If I go through this table, Z value, right here Z value, 2.01. 2 is, yeah, 2. 2.01. 2.01 means second decimal place is 1. So now what is the value here? 2.01 means value this. This is the value. 2.9778. 0.9778. Right? But 0.9778 shows what? It shows this whole probability, this cumulative probability from here to here. 0.9778 shows this probability, this area. But I want this area. How I calculate it? The total area covered from this curve is 1. From 1, you need, when you subtract this one from 1, you will get this remaining, right? So the answer here should be 1 minus 0.97, 1 minus 0.9778. This is the answer, this probability. Right. The answer is correct, right? 0.0222. So another way is by looking at this table. When you look at this table, right, instead of finding the area for this side, you can find the area for this side. Because this table directly gives the area to here. So instead of find this area, I find this area relevant to this Z value. What is the area? Right? Since this is a symmetric distribution, if I find the Z, if I find the probability related to minus 2.01, right, this side, we can get it from here. So find minus 2.01. Minus 2.01 is this value. This is the value, 0.0222. Right? So the answer, directly you can get from this 0.0222. The same answer you can get from both tables. Right? Same answer you can get from the both tables. So please try the other questions, other 3 questions. Any questions? So is it greater than or equal minus 1? Here again we need to draw the diagram. Right, draw the standard normal table distribution is a random variable here. Minus 1 you can mark this way, right? So this is equal minus 1. So what is the area I want to find? Is it greater than or equal minus 1? Is it greater than or equal minus 1 means minus 1 here. Right? When we go to this side, is it less than or equal minus? So is it greater than or equal minus 1 means this side. Right? So I want this shaded area. So how we calculate this? From the first table, we can find this area. From the first table, we can find this area, right? So answer we can get from the total area under the curve is 1, probability is 1. 1 minus, I can calculate the probability is set less than minus 1. 1 minus probability is set less than minus 1. Is it less than minus 1? Less than minus 1 in this area. This area is the probability. Is it less than minus 1? Is it values less than that point? Right? So is it less than minus 1? Directly I can get from here. Here is set for negative values minus 1, minus 1.0. 0.1587, 0.1587. This is 0.1587. So from this, we can make the answer. 1 minus 0.1587. Right, any questions? Right, now the next one is said in between minus 2 to plus 2. Right? Set is in between minus 2 to plus 2. So you can go the diagram. Is 0, right? So mark we say minus 2 here and the plus 2 here. Right? So I want the area. It said in between minus 2 to plus 2 means from here to here. So the area under the curve I want is say. Right? So how can we calculate it? We can calculate it how we calculate this? If we use the second table from here to here, we get the whole probability. If we use the second table gives probability for the whole from probability like 0 to this whole area gives from the second standard normal table for the posterior, right? And from the first table, from the first standard normal table, we can get this area. This is for minus 2. So from the first one, if I subtract the second one, you can get the remaining. Right? So I can get this by calculating probability. Is it less than or equal to minus probability? Is it less than or equal to minus? Probability is less than or equal to from the standard normal table in the second table right here. Plus 2, less than or equal to 2 is this value, less than or equal to 0.9772, 0.9772 this probability, 0.9772 minus the probability is set less than or equal minus 2, minus 2. right? So from the first table, set less than or equal minus 2 means minus 2 0.0228. Right? This 0.0228. So the difference between these gas. You can get the answer here. Right? As this way, you can complete the last one. Right? Instead of 2, you have the 3. Okay, any questions? So you will get some questions like this also, like calculating standard normal probabilities, right? And also, please go to the things we discussed under what is the relationship between the standard normal distribution and the normal distribution, right? These things, please go to the theories. Right, so now we can get the break. And now the time is 12:45. Right, so shall we get 45 minutes break? Then I will upload another Zoom link. I will upload a new Zoom link and we can start the session again 1:30. Right? Please join with the new Zoom link at 1:30 p.m. I want to discuss the last lesson. Right? This is also a very important part, but we are not going to see how we develop a regression model, right? Because I will talk about the regression, simple linear regression model and how we calculate these parameters using manual calculations. There are several formulas also, right? I will discuss these things with you, but when you have the software, directly you can get the model, right, without doing this manual calculation. So, but the theory part is important. Right? And we can talk about the relationships between the two variables, correlation, calculation. These are very important points. When analyzing the data, correlation measurements are very important. So please join again at 1:30 p.m. Right, 1:30. You can start this part and finish. Right? So again, using the new Zoom link, please join at 1:30. Any questions? Right, I will say upload new Zoom link to the Google LMS and I will send to the WhatsApp group also. Any questions? Then thank you very much for joining and please leave from the Zoom meeting and join again at 1:30 p.m. using the new Zoom link. Thank you. This is the last part we need to discuss. Simple linear regression and correlation, right? Here it should be correlation, right? So what we are going to discuss here, here the learning outcomes by studying this one, what you can do, you will be able to get this knowledge, that is to illustrate the basic ideas of linear regression and correlation. What is mean by correlation? and how we calculate it and what is a linear equation, right? And you can identify, you can understand how we create a simple linear equation model. That is, we are going to do some modeling part for a given data, right? And how we interpret the regression coefficients and how we calculate the correlation coefficient. We are going to talk about these things. Okay. So what is simple linear regression model? Now please read this slide, right? And you have some graphical output. This graphical output we discussed under the descriptive analysis section. The name for this is the scatter plot, right? Suppose you have data like several number of students, you have the data like their attendance as a percentage value, their attendance to the class and the marks they obtain, right? Their attendance, the student attendance and the marks they obtain for the final exam. Student attendance for the class and the marks they obtain. Right? Suppose I record these two for 100 number of students. 100 number of students. Right? Here, this is the scatter plot. This graph we called as a scatter diagram. Right? Now, please read these points, and at the bottom of the graph, it says independent and dependent variable. Please read this. What it says. Can't you hear me? Can't you hear me? Okay, right. 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 Now, think about this diagram, and here I give the data. Right, this is actually this is the data set relevant to this output. Right? What simple linear equation model says? Simple, we have some terms, simple linear regression model. Why sound is not enough? Right. Now, when you compare this data and the scatter diagram, right? This is the scatter diagram, or we can say it as scatter plot. Now the sound is okay. Is the sound okay now? Can you hear me clearly? Okay, no?
Okay, madam.
Right, thank you. Right, right. So here scatter plot. In the scatter plot, using the scatter plot, I plotted this data set. That is, for an example, suppose I consider 100 number of students, and I record for each student, I record their final year marks, final exam marks, and their attendance. So this is for the second student marks, final term test mark, and the attendance, right? Like this way, for the 100 student, I have these two. So actually here, we have two variables. We have collected data from this 100 number of students for two variables. This variable I can denote using capital English letters. So this is X and this is Y. No, another way, right? In the graph for the X-axis, we get the attendance, and for the Y-axis, we have right? For the y-axis, we have marks. This is y. So, clearly I have two random variables here collected from the same individual. Right? So then what is simple linear regression model? And you can identify this scatter plots for these 100 number of students, it shows you or it describes you how the how the attendance vary, how the student marks vary with their attendance. Suppose I want, as a researcher, I want to identify how the student marks vary with their attendance to the class. Is there any relationship between the student marks and their attendance? Right? Which type of a relationship it has, whether the attendance increases, attendance to the class increases, marks also increases, or whether attendance increases, mark shows decreasing pattern, or there is no pattern. Right? Oh, whatever the pattern we want to identify. For that, we collect data and I can draw the scatter plot. Right? From this scatter plot, if I ask to give some comment, if I ask to comment on this scatter plot, I can say that, right here in the x-axis we have the attendance and the y-axis we have the student marks. If we consider these dots, these are paired observation, right? Like here, here I have some student, his attendance is this value and his marks is this value. Like some paired data are plotted. So I can say when the attendance of the student increases, their marks also increases. Right? Attendance increases, the overall pattern can say like this type. It increases as a linear line. But the data scattered around this linear line. All the data points are not in this linear line. But by looking at these data points, right? We can give some by considering the overall shape of these 100 number of data points, I can say that when the attendance increases, student marks also increases, right? So what we can say is that by looking at the scatter diagram. What is simple linear regression? In simple linear regression, we are going to model. We are going to find some model between dependent and independent variable. We are going to build some model between some two variables. One variable we called as the dependent variable, the other variable we called as the independent. That means one dependent variable depends on the independent variable, right? So we are going to build some model, some like some formula between these two variables, right? When there is only one independent variable in the regression line, we call it as a simple linear regression model. And we are talking about the linear models only. When there are more than one independent variables in the model, we call as it multiple linear regression model. For an example, here I have marks in the y-axis, attendance in the x-axis. So here this independent variable and marks can depend on the attendance, right? Not attendance depend on the marks, right? We can check whether the marks, student marks depend on the attendance. So this is the dependent variable and this is the independent variable. Sometimes now here we have only one x and one y. Sometimes we have more x variables, like more independent variables, right? Normally we denote in the y-axis, we denote the dependent variable, and for the x-axis we get the independent variable. Then what is independent and dependent variable? Independent variable is a variable that provides the basis for estimation. Dependent variable is a variable that is being predicted or estimated from the independent variable. If I know, right here, suppose I want to find out if the attendance is 90%, if some student attendance is 90%, what is the marks that he can obtain, right? How I find it? How I find it? From the available data, you can plot the data, and if you can fit a line like this, if you write, this is we called as a linear regression line. If you can fit a line like this, by using this one, I can find if the attendance 90, what is the value that the student can get for his marks, right? So this depends on the independent variables. And so, so in the regression, simple linear regression models, right? We write the term simple means I have only one x variable, and I have another variable y, dependent variable. I have only one independent variable, right? So we call linear, but we consider the linear relations only. That is, x is as x only without x, like x square, right? Not like a quadratic term. So here we are going to consider a linear relationship one. Linear relations, the simplest form of the relationship between the two variables is the linear relationship. The linear relationship is one that can be graphed with a straight line. So here it shows the linear, there is an increasing pattern. We can show it using this green color line. It's a straight line, linear line, not a curve-shaped one. Okay? So it's a linear. If I can find an equation for this, I can say it as the simple linear regression one. Okay? So this is the equation for the simple linear regression model. The term linear refers to the linearity of the parameters of the regression model. And here we use the straight line to predict the values of the dependent variable. Actually, we use this linear term not regarding the x variables. Here, when x square term also becomes, we can consider again it as another x dash term, linear one. But it says the coefficients are linear, these parameters are linear. What are these alpha and beta values? We call these are the parameters in the model. Right here, using the data, we can estimate those. So the form of the linear regression model is this, right? We write y values using x value. How we write it? Some constant, some parameter alpha plus some parameter beta times our independent variable plus some error term. Right? We can write this as E O using this epsilon notation. Right? So this is the form of the simple linear regression model. We use some terms for this. Alpha means the intercept, right? Alpha means the intercept, right? This is x-axis and this is y-axis. So alpha means the intercept of, if we write this line as y equal alpha plus beta x times error, right? This error this error always happens because you can see all the data points are not in this line. So there is some error terms here, but we can pick the model. Using the model, we can calculate this alpha and beta values. We have the data points, right? So alpha is the intercept and beta is the slope. Alpha is the intercept of the intercept and beta is the slope, right? Slope parameter. And E is the error. This is error. So if you have the data, XY data, you can calculate what is this alpha and beta, and we can find what is the model. If you know the alpha and beta, we can find the model. So how we calculate this alpha and beta, right? How we calculate these alpha and beta values? We calculate these values using these formulas, right? The beta value here for the sample data, right? For the sample data, when we estimate alpha and beta, right? We can denote those as simple A and B. So the fitted regression line, that is here you can mention it as fitted regression line, that is simple y is equal A plus bx means I know what is A, what is B. If we know these values, there is no error term. So using the data, we can find for any x value, we can find what is the y. And we call this as the fitted regression line. So now how we calculate A and B using the sample data, we can use in manual calculations, we have to use these two equations, right? A can find y bar minus bx bar, that is x bar y bar means of the data in the x variable and the y variable. And we have to calculate the summation values to calculate B. Right? So it's a very big formula here, right? But if manual calculation, definitely these formulas should be provided. Otherwise, we cannot remember these things. We cannot memorize these things at the exam hall, right? And also it is useless. මේ equations මතක තියාගන්න අවශ්‍ය නැහැ. ඒක මොකක්ද වෙන්නේ, අපි linear model එකක් fit කරනවා. අපි line එකක් linear line එකක් fit කරනවා. Original line එක ගත්තොත් original line එක ඇත්තටම y some constant parameter එකක් plus beta with our independent variable plus some error term. So you can see some error in the data point. So line එක y වලින් පෙන්නන data points වල මේ විදිහට තමයි y data points x එක්ක තියෙන relationship. Right? So when we have the sample data, you can calculate these alpha and beta values. then we call it as the fitted regression model. I can find a line like y equal 2 plus 3x. So we call this as a fitted regression. There is no linear term, no error term. I can find this type of what is the relation. That is the linear line. So to estimate this alpha beta, we use these formulas. So here in this question it says you have given some data for x and y variables and you have provided all these summation values required to calculate b and a, right? Using all these values, we can identify what is the fitted regression line. Fitted regression line. So first what we can do is, first we need to plot this data. First we need to describe the data points in x and y. You have the paired data. First you need to describe it. How you describe these two variables, because according to the question, if you read this question asks to fit the regression line between x and y. That means we are going to talk about some relationship between x and y. x හා y කියන variables දෙක අතර තියෙන සම්බන්ධයක් ගැන තමයි අපි කතා කරන්නේ. Right? එහෙනම් මේ වගේ වෙලාවකදී the most suitable graph to present this data is the scatter diagram, scatter plot. Right? So you have paired data for how many data points you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data points. Right? Read this question. Read the question. This question says you from a paddy field, 12 plants were selected at random. You selected 12 plants. The length of pencils and the number of grains per cell of the selected plants, so the length and the number of grains, right, x and y, for the selected plants are given here. The results given in the following table, and you are asked to fit a regression line, right? So you have given what is x and y, you are asked to fit a line. So first thing is, and several other information also given, first thing is draw the scatter plot. Draw the scatter plot. Right? How we draw the scatter plot? When we draw the scatter plot, always for the x-axis I get x variable, that is the independent variable we get for the x-axis. For the y-axis we get the dependent variable. Okay, now getting one by one observation, I want to plot, right? So first you need to mark the range and start from 0, right? In the x-axis values, what is the minimum value? Minimum value is 19.8. Maximum value, it can go up to 24.9, right? 19.8 to 24.9. So I start to draw from here, right? I suppose I start from 15, right? 15, 20, 21, so 25, no, let's say 18, 20, 22, 24, 26, right? So now data in the y-axis, we have the values from the minimum value 90 and the maximum value goes up to 137, right? So I start from 90, 100, 110, 120, 130, 140, right? Now I start to draw. So the first data point is x 22.4, y 95, x 22.4, right? This is 22.4 and this value like this, and y is 95. So this is the point. Then I go to the second one, x 23.3, right? Y 109, 23.3, 109. Like this. And so this point is 22.4, 95. Like this way, I want to draw all these dots. 24.1 x side 24.1, y 133. 133 means value here. Okay. So try to complete this diagram. Try to complete this diagram and see whether you can get finally you can get a graph like this. Right? You can try to draw all the dots, and finally we can get a graph like this scatter plot. Any questions? This is how we draw the scatter diagram, right? After that, I will show you how we get the linear model. Any questions? Can you draw this one? Right? Then you will get this type of diagram, right? You cannot join these dots using lines, right? If you join these dots using line, it is totally wrong, right? This joining of the lines using dots using a straight line is totally wrong, right? This is a scatter diagram, not the line chart, right? There is no any meaning if I join these 2 points with a straight line. There is no meaning for that joining. Okay. So by looking at the scatter diagram, right? That is, I describe x and y. The relationship I can see when x increases, can see some increasing pattern of y also. When x increases, y also increases, right? You can see some pattern, but there is a big scatterness of the data, right? So we can say that we can fit a linear line covering all these data points. We can fit some linear line according to how these paired observations are goes. Right now, I want to find what is this line. Right? I want to find what is this line. Y is equal alpha plus if I estimate those values, a plus bx. What is this a and b values? What are these a and b values? I want to calculate this, right? Then if I calculate this A and B values, I have some equation, like some model. We can say it is a model, fitted line for the data. So how we calculate these A and B values, you have to use the formulas, right? These two formula we can use, right? To calculate A, I need Y bar and X bar values, right? After that, again, I need B values. So what is B? Right? B is what? According to this formula, B is, right? I'm not going to talk about these terms, right? These terms have some meaning, some of square of X, Y. We are no need to talk about these, right? So how we calculate B, we get the product of XY values and get the summation, right? We subtract summation of X value multiplied by summation of Y values, right? And we divide this quantity from N. In the bottom of the line, right? Summation of A, we consider the X square values and give the summation and minus summation of X values and get the square, and we divide it from the number of data points. This is what this equation says. So after that, we can substitute that B value for here and calculate value for A. So I need this summations, that is summation of X value, summation of Y value, summation of XY terms, summation of X star terms. These terms you need to get the value for B. Right? So here in the question we have given, right? It is given to you, right? What is X bar, Y bar, and all these values are given to you, right? So from substituting these values here, we can calculate that A is minus 63.567 and B is 7.93. Now, what is my equation? Y is equal model A plus BX, right? So I can write now, I know what is A. A is minus 63.567 plus B. B is 7.93x. This is my fitted regression line. This is called as the fitted regression line. It's a linear line. It's a linear line. I have only X in one independent variable. Another way we can describe this is to explain, right? To explain what we have in the Y, to explain the number of grains, right? We consider the length only, right? Here to explain the student marks, we consider the attendance, variable attendance. Okay? So that is a simple regression model. And we have only one X variable. Other than that, other than this one X variable, there may be several other X variables, independent variable that the marks can vary. For an example, number of hours spent for the studies per day, or number of hours spent at the library per week by each student, rather than the attendance for the class. Like that, there may be several factors, X variables, independent variables that can affect your Y, right? Dependent variable. So in that case, if we consider a lot of X variables, we call it as multiple linear regression. Multiple regression. sounds අඩුයිද?
මැඩම් ටික ටික ගියාම ඇහෙන්නෙම නැතුව යනවනේ.
සමහර වෙලාවට
ඔව් මැඩම්. ක්ලියර්ම නැතුව ඇහෙන්නෙම නැතුව වගේ යනවනේ.
connection ප්‍රශ්නයක් බලමු. Hello. දැන් ඇහෙනවද? Hello. Hello. Can you hear me now?
ඇහෙන මැඩම්. Yes මැඩම්.
Hello. දැන් මාව ඇහෙනවද පැහැදිලිව?
ඇහෙනවා මැඩම්.
ඔයගොල්ලන්ව දැන් මට ඇහෙන්නේ හරි හිමි. හරි
ඔව්.
sounds. මාව හොඳට ඇහෙනවද පැහැදිලිව?
ඇහෙනවා මැඩම්. දැන් ඇහෙනවා.
Right. මට වෙනසක් තිබුණොත් කියන්න sounds වල.
හරි මැඩම්.
හරි. මේක right, we discussed about how we fit the simple linear regression model. Right? Simple linear regression model means, simple means we have only one x variable. We have only one independent variable. That is, here I have two variables. As the dependent variable, I have marks. I think that student marks depends on their attendance. Student marks depends on their attendance. So I want to test it. I want to check whether there is any relationship between the student marks and their attendance to the class. Right? So in that case, what we do is, in statistics, what we can do, first we explore this data. First we describe the student marks and their attendance by drawing a scatter plot. When you draw the scatter plot, you can see this type of diagram, and the data has some scatterness, big scatterness. But when we look at the overall shape, මේ data ටික දිහා overall ඔක්කොම data ටික දිහා එකපාරට බලුවොත් මට හොඳට පේන දෙයක් තමයි ළමයිගේ attendance වැඩි වෙද්දී ඒගොල්ලන්ගේ marks උත් වැඩි වෙලා තියෙනවා. Right? So we can see that when the attendance increases, marks also increases. Right? So we can say that there is some increasing pattern of increasing attendance with the increasing of marks. Right? So we can find what is the relationship between the marks and the attendance of the student. Right? What is this? What is the formula? Which formula we can use to represent it? Right? So in here, what we do is we fit the regression model. In the regression model, here this is a simple regression model because I have only one x variable, and we say this is a linear regression model. මොකද linear regression model එකක් කියලා කියන්නේ මේක තමයි simple linear regression model එකේ form එක. linear regression model එකක් කියන්නේ මේ alpha beta කියනවා linear terms වලින් තියෙන නිසා. මේවා linear terms වලින් තියෙන square terms වලින් නැතුව. නමුත් මෙතන instead of x we can use x square. Then also it is linear because here for the x if I use x square, right? I can consider this as another x variable, double dash, a new x variable. Again, the model is linear. But if we say it is not linear according to the parameters, right? So here this alpha and beta we say, like in population parameter values, alpha and beta are some unknown values. This is the simple linear regression model. Y plus alpha, y equal alpha plus beta times x plus some error term. This E is always there because we can show some scatterness of the data, right? So there is an error term, always there is an error term. But now what we are going to do, this linear regression line, suppose that this is related to a population of data, right? So I have the sample data. So using the sample data, what we are going to do, we are going to find the fitted regression line. We call it as the fitted regression line. What is the fitted line? Right? If we talk about the fitted line, there is no error term here. I calculate these alpha and beta values using the sample data, and now there is no error term. I can obtain a line like this. You know what are the values for A and B? Simple A and simple B. We use these A and B terms, right? Because to denote the estimate values for alpha, beta. Right? When you have the sample data, you can estimate A and B. To estimate A and B, you need to use these two formulas. මේ formulas දෙක පාවිච්චි කරලා අපි AB හොයන්නේ. හැබැයි ඒ formulas වලින් AB හොයන්න XY data points වල මේ summation values වෙනම අවශ්‍ය වෙනවා. Right? So here we can find A, if we know the Y bar value and X bar value, we can find, but we want to know B value. B value we can obtain from this formula. Right? Here what it says, right, at the top of this line, we have summation of xy terms minus summation of x terms, summation of y values, the whole quantity divided from n, and this whole quantity we divide from this quantity, that is summation of x pair values minus summation of x values pair divided from the number of data points. So these values I can obtain, and I can obtain these values if you have the data. What is by the summation of y? Summation of y means you have the y data points for y random variable. Right? So simply it is the summation of these values, 95 plus 109 plus 133 plus 1 up to the final value 108. This is summation of y, right? Like we said, this is summation of these x values. So we can calculate. Then we want to get the summation of y square, right? Here x pair value, right? So x pair value is the one by one, I want to get the square of these x values and get the summation. That is summation of x square values mean 22.4 square plus 23.3 square. Like the final one, the last one is summation 22 square. Like we say, we have to calculate this. So here the summation of xy term. We get the product of these each term and get the summation. From this one, we calculate this model. That is, what are the values here? It gives A is minus 63.567, B is 7.93. So using these values, I can write the model. This is the fitted regression line. Y is equal 63.567 plus 7.93x. that is in this line. If I can write this line, the fitted line is y is equal 60 minus 63.567 minus 63.567 plus 7.93 7.93x. What is y? Y means the student marks. What is here y means the y is the number of grains, and x is the length, right? Number of grains and x is the length. So how the length vary, the y vary, we can find. If you want to find for the x value 24.5, what is the value for what? X. If x value is 24.5, suppose I want to find what is the value for y. Simply you can substitute the value for x and get the answer. Right? Instead of x, I can substitute 63.567 plus 7.93. Instead of x, I can substitute 24.5. So solving this, you can get at 24.5 value for the x variable. What is the y value? This value, actually, it is the value on the line. Okay? This value we can calculate. So we call this one is like interpolation. Within the data range, we interpolate, we do some interpolation. And so this is the importance of regression. In regression, what we do, we identify the relationship between the x and y variables and pick some model. Here we discuss about the linear model only. Sometimes it may be non-linear models. Right? So here we have only one x variable. One x variable. But sometimes that one x variable means x variable එකයි මෙතන තියෙන්නේ. ඒ කියන්නේ x variable එකයි කියන්නේ උදාහරණයක් විදිහට මේ example එක ගත්තොත් students ලගේ marks වෙනස් වෙලා තියෙන්නේ අපි බලනවා attendance එක්කද. Attendance එක්ක student marks වෙනස් වෙලා තියෙනවද? I have only one independent variable to identify the variability of the dependent variable. How the marks vary? Is there any association between attendance and marks? Right. Other than that, student marks can vary with several other x variables. Right? ළමයි පාඩම් දවසකට පාඩම් කරන පැය ගාන, ඒගොල්ලෝ week එකකට live යන වාර ගාන, right? ඒගොල්ලන්ගේ average monthly income of the family. මේ හැම දෙයක්ම බලපාන්න පුළුවන් ඒගොල්ලන්ගේ marks වලට. So there may be some several independent variables like average monthly income of the student family, the number of hours spent on studies per day, number of hours the student use the library per week, number of times the student goes to the library per week. Like that, several factors we can consider and check whether those has some influence of my dependent variable, student marks. In that case, it is not simple linear equation, it is a multiple linear equation. ඒ කියන්නේ අපි y වල variation එක, marks වල variation එක අපි present කරන්න පුළුවන් x variables මොනවද කියලා බලනවා. වගේ දෙයක් තමයි එතන වෙන්නේ. Right? So this is the idea of the regression models, simple linear regression models. Right? So for your exam, right? For your exam, you should be able to draw a scatter plot. If I give you a data set like this, right? If I give you a data set like this, x and y values, you should be able to draw the scatter diagram. Right? always we get the x variable to the x-axis, independent variable to the x-axis, dependent variable to the y-axis, right? I'm not expecting to calculate the regression line. Regression line එක calculate කරන්න දෙන්නේ නැහැ. ඒක ඔයගොල්ලෝ ඔළුවේ තියාගන්න. කවදා හරි මේක ඔයගලන්ට වැදගත් වෙයි. So after third year, fourth year වලදී on a way, but using the software you can get the line at once when you input the data, right? But this line calculates the values, calculate theoretically using this. Right? Any questions? එතකොට මේකේ මොඩල් කරන එක ඕන වෙන්නේ නැහැ. මට ඕන කරන්නේ ස්කැටර් ප්ලොට් එක අඳලා කමෙන්ට් කරන්න පුළුවන් මොකද? මේකෙන් මොනවාද පේන්නේ? Right? Any questions? Right. And this is also a very important part, right? The correlation. Right? Correlation between or the association between the two variables. To which type of variables? To quantitative variables. Right? For an example, earlier also I have two quantitative variables. I have y variable like student marks and the x variable named as attendance. I have two quantitative variables. Both are quantitative. Represent some quantities, not the qualities. Not like gender, education, qualification. Right? So correlation measures the relationship or association, right? It is a measure of association, like measure of central tendency, measure of dispersion. Correlation is a measure of association which measures the strength of the association between two variables. Earlier we discussed about some modeling part, right? Here this is not model, but just I'm going to talk about the association. What is the strength of the association between two quantitative variables, right? What is the correlation measure we use for this is the Pearson correlation. The name says Pearson product moment correlation. This is a really important measure, right? To identify what is the relationship between the height and the weight, or like the diameter value and the length, height of the tree. So we can calculate the correlation measure. Is there any association? We check it because the both variables are quantitative variables. You cannot calculate this measure, Pearson correlation measure. Right? This measure we call as the Pearson correlation measure. You cannot calculate Pearson correlation measure for the two variable, like for an example, suppose you have some student marks with you have another variable gender. To identify the relationship between these two variables, you cannot calculate the Pearson correlation, right? Because gender is not a quantitative variable, it's a qualitative one. And here, to calculate the Pearson correlation, you should have two quantitative variables. Then see what this Pearson correlation measure gives you. The Pearson correlation measure gives the linear relationship between the two variables. It gives the linear relationship only, right? What is the linear association? If I have two variables like x and y, Pearson correlation discussed about the linear relationship, whether it is a increasing, linearly increasing, or linearly decreasing. What is the size of the value, size of this association? Okay. And this can be used only for the interval or ratio scale data and measures the linear association. Right? So here you have some note regarding this correlation measure. Sometimes we call it as the Carl Pearson correlation measurement also, right? We use the name Pearson product norm and correlation coefficient. Now see, here you have 5 graphs. I will show you how we calculate the correlation coefficient value. Right here you can see for these 5 graphs, right? Under these 5 graphs, you have given the correlation coefficient value. Here it says in the first graph, always I have one variable x and the other variable y. These two are not dependent and independent, two quantitative variables, right? And here the correlation coefficient value, if I calculate it, it is +1. Here it is not +1, right? This should be -1. Please correct this one in your handout, right? In your lecture note, correct this one. This the +1, this should be -1. Negative side. What this value? Here it says the correlation coefficient between the two variables according to the data. It says the correlation coefficient is a value greater than 0.7. Correlation coefficient is a value. Here we can find a value greater than 0.7. And here it is greater than -0.7. It was for the negative side. And the last graph, if we calculate the correlation coefficient between the x and y, we will get the value. Sometimes we will get 0, no correlation coefficient. Here you can get some idea, right? That is correlation coefficient is +1 or -1 if all the data points are on this straight line, linear line. And here all the data points are on this linear line. As this increasing pattern or decreasing pattern. Here you can say when x increases, y also increases. When x increases, y decreases. Right? Here also when x increases, y also increases, but data shows some scatterness around the linear line. Here when x increases, y shows some decreasing pattern, but all the data points are not on the line. Some of the data points can be on the line, but there may be some scatterness of the data. Data scattered around. Right? You see, data scattered. Scattered around the linear line. Here, I cannot see any linear pattern. Right? If you hit a straight line, there is a big scatterness of the data around the line. I cannot assume whether it is increasing pattern or decreasing pattern, right? Or sometimes the suitable line can be a line like this, like a curve shape. This is not a linear line, right? Because of that, if we calculate the correlation coefficient between these type of data, we will get the value very close to 0. So now you can get some idea about which type of a measure is this correlation measure. Right? Which type of a measure is this? Actually, correlation coefficient. Pearson correlation coefficient we denote using the notation simple R. We use the notation simple R to denote the correlation coefficient for the sample data. Right? Suppose you have the population of data. For the population of data, it is rho. Right? Now, we deal with the sample, so simple R. R is a value in between, right, -1 to +1. Like probability, it can vary, it can be 0, 1, in between 0 and 1. So Pearson correlation value, simple R is a value, it can vary from -1 to +1, including these two. Okay. So according to this, I can interpret for the data, I can calculate what is the value for R. According to the value, I can interpret the relationship. This relationship always a linear one. Right? We are talking about linear relationships only. Linear relationship between two variables. Okay. Here you can see compare this line number line, right? Here, this is 0, right? This is 1. This is -1, right? So these are positive values, these are negative values. So these are the values that R can take. Right? So when R equal +1 means R is equal +1 means, right? There is a perfect linear relationship. R +1 means there is a perfect linear relationship. Perfect linear relationship. That means all the data points are on the line. But if you get the value for R in between 0.8 and +1, we can interpret as there is a strong positive linear relationship. Strong positive linear relationship. Strong positive linear. Right? And also if it is in between these two, right, 0.6 to 0.8, right, we interpret it as moderate. Right? Positive moderate linear relationship. Right? If the R values in between from here to here, right, say it's a mild linear relationship. And if R is -1, you can say there is a perfect negative linear relationship. Negative linear relationship. When X increases, Y decreases. Right? So if R is in between -1 to -0.8, can say strong negative linear relationship. Strong negative linear. Right? So R in between these two, strong moderate linear negative linear relationship. And if R value is very close to 0, from here to here, this point we say there is a very weak linear relationship. Very weak linear relationship. Data scatter, but we cannot identify any linear pattern. Right? So if you get for the R, if you get a positive value, we say we have a positive linear relationship. If it is a negative 1. If R gets a negative value, we say it is a negative linear correlation, negative linear relationship. But according to the size of this value, we can talk about the strength of the relationship, whether it is a perfect one, whether it is a perfect linear, strong, moderate linear, weak linear, like that. We can talk about the strength of the relationship as well as the direction. According to the positive one and the two, we can talk about the directions. Right, any questions? So here you have given the scatter plot, right? And here, this is the scatter plot between the two variables, data in the two variables, pulse 2 and pulse 1. Suppose I want to identify both variables are quantitative variables, continuous scale, quantitative ratio scale data. Suppose I want to identify whether there is any relationship or association between pulse 2 and pulse 1. First, I draw this scatter plot. After that, I calculate the correlation coefficient value. Right? This is the calculated value. Pearson correlation of pulse 1 and pulse 2. Right? Pearson correlation between pulse 1 and pulse 2 is plus 616. Right. Now, this is this output I obtained from the statistical software Minitab. Right? Here also another important value here, the p value. Right? This one, I think if you have another statistic course unit, you can learn what's the p value here, right? Actually, in the statistical software, when you use the statistical software, we come to the decisions. Right? Earlier, we discussed about in hypothesis testing, we get the decision by calculating Z calculated value and some Z value based on our alpha critical value. But we can come to the decision by considering this p value also. This is a generated one. This is a given one from the statistical software according to your data. Right? Manually, I can manually calculate this one also, but when you have large data set, I cannot do it. So software gives related to this type of test. Always the software gives what is the p value. So I'm not going to talk about how we interpret this one and how we come to conclusion here. But just I want to show you how you interpret this R value. Right? So here I can say that there is a point R value is 0.616. No? So R value is 0.616 means we can say that in this range. Right? We can say that there is a positive moderate linear relationship. Right? It's true. Right? If we look at this diagram, there is a high scatterness of the data. Right? The scatterness is very low here, but when you go to this side, you can see the data scatterness. Right? With scatterness of the data. So you can say there is a moderate positive linear relationship between pulse 1 and pulse 2. Right? Don't worry about this value. Just look at this value only and you can write the interpretation. Then how we manually calculate this value, if you want to calculate this one, it's in manual calculations. This is how we calculate. This is the formula. This is the formula to calculate R. Right? simple correlation coefficient are the correlation coefficient, right, between X and Y, right, it comes from this, and the simplified form of this formula is this, right? If you want to calculate this one, I can provide you the formula, right? And simply you have to substitute these values, summation of xy, summation of x terms, summation of x and summation of y, you need to calculate this. Now you have another example, right? For this example, please draw the scatter plot and try to calculate, try to check whether you can calculate these values, summation of x, y, x terms. Right here, I explain this how we calculate it using Excel. How we calculate these terms using Excel. But if you want to manually calculate it, you should know, right? So get a few minutes and see how to draw this plot and how you calculate the correlation coefficient R. How we calculate the R value. Right, please get 2 minutes and do it. Right, at the exam, you should be able to draw this scatter plot as well as should be able to calculate the correlation coefficient. I will provide you this formula. Right, I will provide you the formula. You should be able to calculate it. Right, here it asks you to find out the correlation coefficient between seed yield and plant height. Right, seed yield and plant height. Then it is given there for you what is y and x. Actually, we should be able to identify this. That is, we want to see whether the seed yield depends on the plant height. Right, so reverse is not true, I think. Right, we can talk about how the yield depends on height. Right, so when drawing the scatter plot, normally we get for the x-axis we get our, right, for the x-axis we consider our independent variable and what the dependent variable we consider for the y-axis. Right? So considering each one by one pair, you can plot this. I think you can get this plot, right? It's not difficult. You can draw this. Now, if you want to calculate R, you should construct these summations, right? If these are given, it is okay, right? I will provide, normally at the exam, we will provide these values, what is summation of X, what is summation of Y, right? All these terms here, what is summation of XY, summation of X, summation of Y. N means the number of data points, right? N means how many data points are there? 1, right? Plant 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. N is 12, right? Here N is not 24. Here I have 12 data points and 12 data points. The total data points is not 24, right? I have the paired data, like for the first plant, what is his CD and the height. Second plant, the CD and the height. Like I said, the 12th plant, CD and the height. Right? So please understand these things. So at the when we solve the bottom, right? Bottom part, what I want with my square, sigma y square term, then sigma x and sigma y here. So we need these 5 only, right? So how we calculate this 5 values, sigma y means the summation of these values, right? 5.22 plus 8.13. Okay, how many data points? The last one, 7.56. Summation of x means 94.2 plus 69.3 plus 81.3. Then summation xy. Summation xy means 5.22 times 94.2. This product sum, right? 8.13 times 69.3 plus, like this way, because 7.56 times 81.3. This is summation xy. Right? Then summation x square means the summation of square terms, 94.2 square plus 69.3 square, right this way. So the 81.3 square. Get the square values and get the summation. So substituting all these values, you can get the answer. Right? The final answer here is 0.43. It's a very 0.43 comes in this way, 0.43. You can say it's my relationship. Positive, linear, but it's not strong or whatever. It's a my relationship. So here I explain how you use the Excel, right? If you want to do this calculation, very easily you can do it using the Excel sheet, enter Y data and X data and create these columns, right? X pair, Y pair, X, Y. And when you get this, these are the summation of this. When you get the total here, this is the summation of X square. This is the summation of Y square. This is the summation of XY terms. Right? You can practice these things. And this is what I want to talk under the linear regression and correlation analysis. Right? So those are the things, all the things we need to discuss. So I will upload another tutorial also based on the correlation calculation and hypothesis testing, simple questions. So complete that one also, and then if you have any other, when you are doing some questions or when you are going through the lecture notes, if there are any unclear points, right, where you need any help, you can contact me. Right, you can send me an email. This is, I think I gave you the email address, right? This is my email address. Onto that is pp.ac.ak, or you can send me a WhatsApp message. Right? This is provided. Right? You can send me a message. And please complete your quiz, and you can complete it after your exam also, and complete your assignment and hand it over to the department. You can get marks for the assignment and the quiz and the final exam paper. Right? And think about the questions I have given under the tutorial as some sample questions for the exam paper, and also I will upload some another questions also, right? Do these questions and don't go through in the lecture note. There are some calculations, right? Calculations based on the frequency distributions, how we calculate the mean, median. Please don't go through in detail, more detail on these calculations, because in my tutorials, I gave you the two tutorials, right? In those two tutorials, there are no such type of questions, right? I'm not expecting the big calculations in the exam, right? So simply, if I give you a simple data set, some few number of data points, right? You should be able to calculate, like if I give you this type of a data set, you should be able to calculate the mean, median, mode, right? And also you should be able to draw a bar diagram and should be able to identify the scales of measurements and the variable types so that they are discrete or continuous. And also should be able to calculate some probabilities using the standard normal table, right? And should be able to calculate some dispersion measures. How we calculate the standard deviation. I will provide the formula. For the standard deviation, and the required values should be able to get the value, right? And you should be able to write some answers related to the hypothesis testing, like what is type 1 error, type 2 error, what is the meaning of level of significance, how you identify the one-tail test and two-tail test, right? I'm asking questions like these, I'm asking the questions of these type only. I'm not going to say you perform the test and give you a decision, right? Because I'm not expecting this type of number calculations. And at the last section, the regression and correlation analysis, you should be able to draw the scatter diagram and calculate the correlation coefficient and interpret that value. That is, you should be able to say whether it is a strong positive linear relationship or strong negative linear relationship. According to the value you obtain, you should be able to interpret it. Right? So please go through all these things and do your exam well. Right? And finally, I want to show you, I think I showed this point to you, that is Excel data analysis tool pack, right? In Excel, This is also we can use as some statistical software. So in Excel, there is a data analysis tool pack. Right? We will go to Excel. In Excel, under data, right, under data, we can get here, I have no data analysis tool pack here, right? It's not in my Excel. So I can get it using the Excel add-ins. I can get it. How I get it? If you want to get the data analysis tool pack in Excel, what you need to do, go to File and go to Options. File and Options. Right? This is an extra thing for you. Right? File Options and click on here in this right, in this window you can see add-ins. Click on add-ins. When you click on add-ins, it shows these add-ins, right? The Excel has analysis tool pack, right? Analysis tool pack and solver. Excel solver is another add-in, right? It is heavily useful in operational research analysis, right? So I can add this one when I select this one, analysis tool pack, then click on go, right? Then it shows you this one, add-ins, right? Add-ins, click on here and click OK. Analysis tool pack, I want this one, click OK. When I do like this way, you can see under data menu, here you can see the data analysis tool pack. Right? When you click on the data analysis tool pack, shows you what you can do. Right? Here, like you can do some descriptive statistics, you can calculate correlations, right? Well, we now discuss these things, and I think regression analysis also there. Right? Regression analysis, we can go the histogram, right? So lot of statistical analysis we can do. Just you need to enter the data to the software Excel and go to data analysis tool pack and you can get the results. Right, so these are the things I want to discuss with you. Right, I think all of you can access your LMS, right? So I will upload all the required lecture materials and everything in the LMS. In LMS, you have your course manual. Please go through it, and there are 7 lecture notes, right, with statistical tables and lecture recordings, and you have the pulse data set also. Please go through these, right? One day you will need these type of data sets to analyze, right? So the practice is this practice is very useful for you in the future. And there are 2 tutorials, and I have uploaded the assignment also, right? So please complete this assignment. I think you can download this one now, right? Please complete this and submit it to your department. So, any questions? Any questions? If you have no questions, I can stop the meeting, right? So this is the end of the course unit, right? I think I have covered all the parts, but it's a big content, right? Actually, it's a big content. To understand that content, you should have some basic knowledge from mathematics also. Otherwise, this content is not easy. Because of that, I will give you your question paper, Natali, right? Your question paper always a very simple one, right? Because in this stage, we are not using any statistical software, right? අපි ඇත්තටම දැන් අද මිනිමම් මැනුවලි කරන්න අවශ්‍ය නැහැ. මොකද software තියෙනවා. ඒක ඔයගොල්ලන්ගේ level එකේදී ඔයගොල්ලන්ගේ basics ටික දෙන්න ඕන නිසා තමයි මේ manual calculations කරන්නේ. එතකොට මේ manual calculations exam එකේ ගොඩාක් කරන්න දෙනවා කියන එක එහෙම ඒක තේරුමක් නැති වැඩක්. ඒ නිසා manual calculations ගොඩක් හම්බ වෙන්නේ නැහැ. ඒ අර class intervals තියෙනවා. ඒවා නිකන් බලාගත්තම ඇති. right? ඒවත් බලන්න ඒවෙන් ලොකුවට ගණන් හදන්න යන්න එපා. මොකද ඒවෙන් අදහස විතරයි ගන්නවනේ why we develop the frequency distribution, why we develop the class intervals, right? The frequency table is a table. We use this one to draw the histogram. හරි අපි ඒක අදින එකේ ප්‍රයෝජනය තියෙන්නේ අතටම ඒක නිකන් ටේබල් එකක් විතරයි නමුත් ඒකෙන් තමයි හිස්ටෝග්‍රෑම් එක අදින්නේ. අන්නේ ලින්ක් වෙන්නේ කොහොමද කියන එක ලෙක්චර් නෝට්ස් කියවලා තේරුම් ගන්න. right? ඇත්තටම ලොකු කන්ටෙන්ට් එකක්. ඔයගලන්ට අමාරු ඇති තේරුම් ගන්න. එනකට මේ එක්සෑම් එක බය වෙන්න එපා. එක්සෑම් එකට ටියුටෝරියල්ස් වලට ප්‍රැක්ටිස් කරන්න. කරගන්න පුළුවන්. right? notes වල හැම දෙයක්ම අවශ්‍ය වෙන්නේ නැහැ. නමුත් ඒක කවදා හරි ඕන වෙයි. right. Then if you have no questions, I can stop the meeting. Right? No questions?
No, madam, thank you.
Okay, right. Then I wish you all the very best for your exam. Do it well. And please submit your assignment and complete your quiz also. I will upload the quiz to the LMS, right? It's a MCQ type questions you will get, but I think you can complete it after your exam also, right? But assignment you have to hand over to the department at the exam due. So if you have any questions, you can call me or you can send me an email. Right, so thank you very much for joining the lectures. So I stop the meeting now. Right, wish you all the best. Thank you.
Thank you, madam.
Recording